How do you measure weight? What is weight?
I know what weight is. Mass times gravitational attraction.
Little g. That's
Right.
not the same thing.
Okay. That's where gravity comes in.
Right. So
The buoyant force is equal to
George,
the weight.
George,
yeah.
In my egg experiment, when I changed the density of the salt solution by adding more salt, where does buoyancy fit into it?
You have changed the weight of the water that's displaced.
No, I've changed the density of the water, not the weight.
Yes, so you've changed the weight of the water that is displaced by the egg.
You've made it more dense, and therefore you've changed its weight.
I changed the density because
and that changes its weight.
You've actually changed the medium. You haven't changed what you're starting off with. You started off with water. Now you have salt water.
If you change the medium, you're changing the density of the medium. Hence, you're changing the weight of the water that's displaced. Hence, you've changed the buoyant force.
You're just making that shit
up,
George.
Well, we'll have a hangout, Anthony. We'll have a hangout about this then. When I can show my diagram, we can go into this in extreme and excruciating detail that I can explain to you. So if you want to decide on a date, and we can have a hangout about this particular subject with diagrams and preparation.
And I did two hangouts in my channel where I've discussed it in detail.
Rumpus, I want to chat to you offline at some point. Can I arrange? I tried to message you on Skype, but you don't seem to use it that often.
I do. I blocked you after you started calling me names. I could unblock you if you're prepared not to start
Rumpus, that's so funny.
Well, when someone starts using 4-letter words at me on my messaging system, I just say that's not someone I want to talk to. I don't do it to other people. I don't expect it to be done to me.
Word?
Sorry?
Can I see the evidence that I called you a 4-letter word?
I
didn't call you names. I just said that you're a moron.
No, you used the S word at me.
What S word is that?
You called me. You went on and on. Well, this is the excrement.
Shit, I called you shit. That's not really a swear word, is it?
I'm afraid I regard it as such.
Okay, well,
just a quick question about the experiment. What do you consider your constant?
Who, me?
Yes, sir.
Everything that wasn't changed.
But once you changed the water, that was changing one of the constants.
Yeah, that's right. That was my independent variable.
But wasn't adding the say if you added the cork in, that was changing your variable as well, because you were changing what you were placing into the actual experiment.
Yeah, I was changing the mass and the volume, wasn't I? I was changing the volume minusculely, but the mass significantly.
So you didn't have a constant at that point.
Yeah, temperature, pressure. Well, no, not pressure. Temperature of the air, temperature of the solution. They were all constants.
So those were your constants, but you were taking your measurements off of adding the salinity into the water.
That's right. That was my cause.
And of course that's going to change because you've changed the medium as to what's floating and what's not floating.
That's right, because that was my cause.
Okay, so I'm still not understanding what were you trying to prove at that point?
That if I change something, I can make the egg move.
Well, yeah, I mean, if I took the egg and I threw it out the window, I've changed where that egg was placed.
Yeah, exactly. But you guys tell me that the thing that made the egg move was the buoyant force that I did not change.
You did change it.
Yes, you did change it.
You did change the density of the medium.
Once you changed the medium, you changed where it was. You changed that medium, which should have been your constant.
When you add salt to the water, you change the medium. You change the buoyant force.
I didn't change the buoyant force. I changed the density.
You did. You added salt to the water. You made the water more dense. Hence, more weight is displaced by the egg.
Yeah.
The weight displaced, you agreed, is buoyant force. So you've increased the buoyant force on the egg.
George, that's only demonstrated mathematically. I'm talking about real world.
No, it's not demonstrated mathematically. You're just identifying the wrong cause. That's all.
No, I'm not. I didn't change anything else other than the density of the liquid. And if you're going to say that I changed
calling it density, we're calling it buoyant force. You're just not identifying the proper cause.
Yes, that's right. You never understand, Anthony, that when you change one thing, you change lots of things, or a necessary consequence of changing that thing.
Guys, listen, you're doing two things by claiming a buoyant force. You claim it. Hang on. Wait a sec.
Well, why don't you look up? You like using Wikipedia.
No, it's
Why
it's
don't
gone,
you look
George.
up-
George,
wait, Dean.
He's
no,
gone.
it's,
George
it's
is
gone,
gone.
George.
Dean,
It's
I'm
I
tired
haven't
of
gone.
you.
I've not gone. I'm here. Listen, let me go because I need to go in a minute.
Jump
Listen,
right in on me.
listen.
I'm saying,
The
no.
thing I
Why don't you
changed.
go and look up neutral buoyancy.
Yeah, I understand. But the problem with neutral buoyancy is you're going to claim that I've changed the buoyant force, but I didn't change the buoyant force. You're
did.
inferring that. Listen.
When you change the density, you
No,
change the
wait.
buoyant
Let me
force.
get my words out, please. You're inferring that I changed something mathematically, but in real world, all I changed was the mass and the volume.
And that changes the weight.
No,
Only mathematically.
you also
in real world.
chemically you change that water.
There's many things that are
Chemically.
coupled together. Density, volume, weight, gravity are all coupled.
Yeah, but you can only demonstrate one of them. You can't demonstrate the buoyancy and the gravity bit.
We can.
Sure you can.
You can
just
demonstrate
did
the
by
weight.
adding salt to the water.
I'll
You
show you
can't-
all this,
can't- no,
Anthony.
you can only demonstrate it mathematically, but not
I
real
would-
world.
Oh, no, we can
Okay.
demonstrate it by doing things like measuring the weight of the egg in the you could by this in
Well,
my
I'll tell you-
diagram. You may recall I had a little thing wrapped around the egg and then going off to a little weighing thing. And by measuring that in real world, you can see the weight of the egg in effect changes in the
Yeah, you can
buoyant
measure
solution.
the force on the egg. You could attach a little string to the egg, run around a little pulley, and then put it to a scale, a spring scale, and then change the water by adding salt to it, and you'll see that the upward force on the egg changes.
Yeah, but that's caused by pressure, George, not by buoyancy
What
or
is
gravity.
pressure? Pressure is
Yeah.
force per unit area.
Yeah, I'm not sure
Yeah,
you know the difference between pressure and force, do you,
Force is
Anthony?
Pressure.
I do understand the difference. Pressure is force. That's what made the egg
No,
move.
it's not. No, you see, you
Pressure
don't
is
understand the difference between
force.
pressure and force, do you?
Guys, that's pressure causes subs to collapse and causes balloons to burst.
Do you know the difference between pressure and force?
Pressure is a force.
No, it's not.
How is it
Pressure
different?
is the result of a force over
Right.
an
You see, you
area.
don't understand the
No,
difference between
pressure is
pressure and
Pressure
force.
is the concentration of force.
Pressure is a force. End of
No, it's not.
It's in the definition. Just Google
it's
the
not.
definition.
You're
Look,
wrong.
pressure is the concentration of force over an
Right, so
area.
it's a force.
If you want to find the total force on an object, you multiply the pressure or integrate the pressure over the surface area. So pressure is basically a figure of merit. It's a measure of the concentration of force over
Yeah.
area.
So it's a force.
No, it's not a force.
No, Jesus,
Well,
it's
different
a
unit.
function of force.
Well, let them have that. I mean, we're picking gnats' asses here. Yes, pressure is a concentration.
We're not picking that asses, George. We're distinguishing your claim that there's a buoyant force when we've already got a force called pressure.
Pressure is not a force.
Force. Who cares? It's a force. You deny that forces are responsible for the movement of the egg in a medium.
No,
We're
we have
saying
a force that
forces are
moves the egg. It's called
responsible.
pressure.
It's not density.
George, stop rumpusing. The force that moves the egg is called pressure, not
No,
buoyancy.
it's not.
But
It
pressure is not
Pressure causes
density.
it.
Pressure is not density.
No, pressure's the force that moves it. Density makes it.
Pressure is not a force.
The density,
Pressure is
the
the force.
density of the water we can see in the real world. I mean, you go over to the Dead Sea, the salinity in the Dead Sea is much higher than it is in the regular ocean. And you go from the ocean over to fresh water, and the density is different altogether.
So if
Just adding
pressure's not
salt,
a
it
force,
changes it.
can somebody tell me how I'm misunderstanding this? The definition of pressure on screen presented by me right now: continuous physical force. Hang on a sec.
Exerted. You're missing the word exerted.
Yeah.
Exerted is the key word on that. Continuous physical force exerted.
So it's the
You know,
force
this
applied
is
over
what
an
you do a
area.
lot of times, though, Riley. You find these layman definitions and stuff.
Sorry,
It's
guys.
not an official definition or a scientific definition of pressure. Pressure is force per unit area. It's a concentration of force. How
That's like a
concentrated the force
definition.
is.
Go to the definition of pressure in physics you've got there.
This is really weird. I've never known.
No, you had it. You had it there. You had.
Cherry pick.
Pressure in the physical sciences. Force
Per
per
unit area.
There you go.
Yeah. So does it cause an object to move or not?
It's the force.
Wait. What do you
can have
mean?
a very,
So what?
For instance, if I had stiletto heels
Wait.
on and I stood on my scales, I could have a very high pressure, but I could still wouldn't have changed the force as if I would normally weren't wearing stiletto heels.
Yeah, well, that's not the point, though, is it?
It
The
is
point is
exactly the
stand-
point. That's the difference between pressure and
No.
force.
No, but the thing is it a force in the sense that if you put your stiletto heels on and then stand on the scales, is it going to change the fact that you weigh something?
Well, it'll show it have be a different pressure and it'll be a different force. But if I could have the same pressure by having a much smaller weight and then having a smaller stiletto, or I can have an elephant-sized foot and have an elephant-sized area, and it would have a smaller pressure but a different force. The force and the pressure are not.
Now
they
go
are
ahead
not.
and highlight
You
the
can't
next three
derive one
words
just from the
per
other.
unit area. Highlight the next three words.
So, for instance, you could have an elephant stand on your foot, and it probably wouldn't do you much bad. But you have someone with a stiletto with much less force, but with a stiletto heel would puncture your shoe and hurt you a lot more.
I've got
You
issue with that. I've had something smaller than an elephant stand on my foot, and it fucking hurt. It was a horse.
Yeah, well, the elephant's got very wide, horse, but the elephant's got very wide feet, actually,
Yeah.
and the surface area of an elephant's foot is incredibly big, and the pressure they actually exert is very small.
So you science deniers are still going to argue that pressure is not a force?
Pressure is not a force, no.
Look at the next three words of your definition on the screen, dickhead.
It's different
Yeah,
unit.
the word force is highlighted, dickhead.
Yes,
Look at it.
per unit area.
Per
Doesn't matter,
unit
it's still
area.
force, isn't it? Force per
it's
unit
not
area. It's
a
maths.
force. It's a
It
force
is a
per
force.
unit area.
What
It's different
bursts of
units.
balloon or what crushes Rumpus? What crushes a submarine if it's not pressure?
What counts is the
That's force over the unit area.
right, but
What
I could have a
crushes
much
submarine if
I
it's
could have a
pressure
much
is-
bigger force over the entire submarine, but if I had a smaller area over which that force exerted, I'd have a
doesn't
higher
matter.
pressure.
What crushes the
Again,
submarine, please?
The best way to
question
talk
is-
about this is pressure.
You're roboting real hard, man.
you're
Pressure
roboting.
is the concentration of force over an area.
Right. So
It's a
what crushes the
concentration.
submarine?
It's related to force through.
Gentlemen, answer my question. What crushes a submarine?
The force at a particular point.
Right. Force. So pressure is a force.
No, it's not a force.
Pressure is force over
No,
an
it's
area. I
actually
don't.
the weight. The weight of the
Why are
water
we going
creates
down
the
this
pressure.
road? All right,
Because
let 'em
because
handle it.
and
Pressure-
because you need
pressure
to get
is
Anthony to
related
understand
to
some
force.
basics,
That's
George. You
confusing
need
them.
to get people like Anthony to understand some of the basics that they've missed out on in teenage years.
I don't
Is
think
miles
so.
per gallon a
Oh,
distance?
you're roboting. Someone's roboting. Is that-
Schrodinger's, you can't talk at the moment. You're sounding like, you're sounding. I can't even work out the
Schroding,
words.
if you're using voice meter banana, reset your audio.
Yeah, stop using voice modulation. We know what you sound like.
No, I think he's
Just out
using
of
voice meter
just
banana.
to put it into terms, it's not the force of the water. It's actually the weight of the water. It's the weight. It's
That's
not
the same
it's not a
thing.
pressure. It's not a
It's
force. It's a
they're all
weight.
interrelated. The thing is what causes objects to move that are submersed in a medium is the net force acting on that
Am I still
object.
roboting?
Or the change in pressure as I demonstrated.
No, you're not, Cliff.
Schrodinger, you're fine.
Okay. Yeah, I was going to ask, is miles per gallon a unit of distance?
No.
Okay, thanks.
There you go. Good example, Schrodinger.
By the way, guys,
Just because it's got the word force in it, Anthony, does not mean it's a force. If you have other things divided by or multiplied, it makes it a different thing. So, for instance, energy. Hold on. Energy is defined as force times distance. Does that mean to say it's a force? No. Just because it's got a force bit in there does not make the whole thing a force.
So, Rumpus, if I apply pressure to your testicles, is it going to hurt at some point?
Yes.
Right. So it's a force then, isn't it?
No, it's a just like energy is defined as force times distance.
What you
Look,
perceive as pain is the concentration of force, the pressure.
Well, it's actually the force. What it is actually is there's a particular force at a particular point that is actually greater than I can withstand. So although we talk about pressure, it's ultimately the force at a particular point that causes the damage. So you can argue it is actually the force ultimately in the end that pressing on a cell wall, it's the force exerted on that cell.
It's a concentration of the force over certain areas.
Yeah, but when you actually go down to the microscopic level where it's actually causing damage, it's the force.
Let's not go down this road.
Hold on, hold on. If you want to, ultimately, it is a force that what counts.
All right. you're just arguing with him that it's not a force. So
but the point is, but George, we cannot admit to the fact that forces and pressure are the same thing because they're not. Just like energy is equal to force times distance, and Anthony's just seen the word force in the equation, and therefore thinks it's a type of force, and it's not.
At this point,
you guys are negating the math.
The situation.
Position.
Didn't hear any of that. You and George
you guys are literally trying to use the mathematical equation to try and debunk me, but we all know that the force that crushes a submarine is literally the pressure of the water around it is relative.
Right, and the pressure then exerts. If you go to a particular point on the submarine, it's going to crack. What you will find is that there's a particular force exerted on a particular thing in the submarine at a particular point that causes it to break. What the pressure describes is what the force per unit area is. But there's a point where there's going to a breaking point of something, and that's going to be the force exerted, which actually causes it to break. I'll explain that too, if you like, in this hangout.
Sure, we can do that later.
Is with a submarine.
The weight.
If you go down to a mile with your submarine and it reaches crush depth and it gets crushed, there's a concentration of force per unit area that causes stress, that causes the material to fatigue. So if your claim is that the pressure is the force, then why doesn't the submarine crush at 50-foot depth?
Because of pressure isn't enough.
George, when you talk about the limit of something, there'll be some structural part of the submarine somewhere in its where the rings or whatever, in between the rings of a steel, and you say if you apply a force here, it will break. So ultimately, it is actually a force that will cause it to go at some particular area.
You see what you're doing here, Rumpus? You've just reversed yourself, and you're confusing.
No, you're confusing.
You guys are talking past each other. Gavel for both of you, real fast.
The fact you're agreeing that force and pressure are sort of almost the same thing, George, I think it's a bad thing to do. Just because Anthony spotted the word force in the equation for pressure.
Guys, listen, it doesn't change the fact the thing that crushes the submarine is pressure.
No, it's not. It's a force at a particular point that causes it to crush.
Can I ask?
Still pressure.
Can I ask Anthony a question? Because I need a hand.
Sure.
So I'm going to share my screen at the moment, and I've been working on this. I just want your opinion on it. If you've got no opinion, that's fine. So let me just share my.
Let me read to you. Who am I speaking to?
StingRay, Dean. You got me on Skype. Yeah.
Oh yeah.
Yeah. So
I knew it was Dean. I just didn't know what your name was.
Yeah. StingRay. So yeah, I'm trying to make my flat Earth model, and I put clouds in it now, but I can get rid of the clouds.
Right, I'm not seeing a presentation. Oh, hang on, have you got two things? You're muted. Hang on.
No. So what happens is on this kind of meet, when you start presenting, it adds another person as the presenter, which is a duplicate of yourself. I think that's why people are getting confused. Yeah.
But I can see you, no problem.
Yeah, no, sometimes you can, but sometimes you have to click on the other me, because there'll be two me's in here right now.
Yeah, you're right. Yes, you're there. Yes, there's two U's
now.
Yeah.
So,
hang on, let me see. So, hang on, when I'm clicking on both StingRays, I don't see a...
I don't understand, Anthony, but in the middle for everyone else, where the main Hangout window is, we can see Dean's presentation. For some reason, you can't.
Yeah.
You've got a problem.
Weird.
You're doing this in Chrome, Anthony?
Yeah, I'm doing it in Chrome. It does say StingRay's presenting, but I'm just not.
That's all. We've got a picture. Everyone else has got a picture of flat Earth.
You don't see his flat Earth?
No.
Yeah, we all do. In the main window here.
I seem to have Rumpus stuck. I seem to have Rumpus stuck on screen when he's talking, even when everybody else is talking.
Oh, that's because I'm presenting as well. I might be presenting. Yeah, I'll stop. Now
make sure you don't have Rumpus pinned.
Oh yeah, you are presenting Rumpus, you dick.
I was, yes, okay. But now can you see Dean's presentation?
No, but I might have Rumpus pinned. Oh, hang on. Right, sorry. Right, I had Rumpus pinned accidentally. Got it.
Nah,
well done, whoever said that.
Right, so I'll take off the cloud layer. The cloud layer is actually cool because it gives me little shadows as well if I put the shadows back on. Look at that, how cool is that? But, yeah, fuck the cloud layer. So I've got the sun and the moon here on a flat Earth, and this, for all intents and purposes, is the best flat Earth map that I've found that maintains continent sizes somewhat, based on what we know about the lengths of things. If anybody wants to give me another flat Earth map, that's brilliant, and I can swap these out and try them on loads of different things, but I'm just using this for reference. Now at the moment, the sun and moon are 4,000 miles up. and they're 350 miles wide or something. I'm willing to change any of this, but the problem that I've got here, Riley, is this flat Earth map doesn't match observations at all, and I don't know how to make it. Now, I've tried everything. I've tried actually creating a glass dome around this and doing everything based off reflections as well, and I can't do anything that way. So,
which observations are you claiming that it doesn't match?
Right. So so you can see the moon over here, yeah.
Mm-hmm.
So this is the side of the moon that we see. We don't actually see this side here because it's got loads of craters on and that kind of stuff. It's the ass end of the moon that's slightly illuminated here.
But we're looking at this orthographically, though. Can we look at it from the perspective of an observer?
Absolutely. Where do you want to be?
Anywhere.
Okay. So I won't even care where we am, but we'll have a look at the moon cam, and I'll move this up. So moon cam is here. I'll zoom in a little bit because the moon's a long way away. So the issue that I've got here is, this is now like P900 quality, by the way. The issue that I've got here is that this is one orbit of the moon as it's going round.
Libration.
Sorry?
That's libration.
Not to this degree. So the problem that you've got is, yes, to under 5 degrees. This is 30. And this changes the crescent as well. So
yeah, but you need to put a density gradient in for the atmosphere, though, because that's going to have a significant effect.
The only thing that would do is transform it. So I can actually model basic atmospheric refraction, but the only thing that it would do, wouldn't do anything looking up at it, to be honest. But if it gets far away, my observation here will make it lower than refraction would allow it to be. Refraction would keep it high. The more atmosphere that I look through.
So what you're claiming is that you've got a 30 degree libration.
No, what I'm claiming, I don't actually give a shit about degrees at the moment. What I'm actually claiming is something that I can't reconcile. So right now, here on the left-hand side, we're seeing this moon from where Jose is, or Mexico, or Havana, or Florida. Wait a minute. Mexico. Now, if I go down to Argentina, this is what I see. And this is not what I see, or what someone sees in Argentina. If I come up to the United Kingdom, I'm looking at a different...
What makes you say that that's not what we see in these areas?
Oh, because I've looked at... because I did this on a globe model, and I thought, hang about, that crescent on that moon looks... I've never seen this before, ever. So I did a Google search of Argentina moon, and I looked at all the photos, and it's because obviously they're at a different elevation and a different underside of the globe. So their crescent is not like ours in the UK. It never will be. Theirs is on the top. Ours is on the side.
To validate your claim, I'd need to see a time and date of the crescent.
No. Listen to this. This is my... I'm not making any claims. I'm asking, how the hell do I make it? You can see the moon here from the UK, yeah? We can see the bit that's facing us. Now, at the same... Yeah.
Claim. You are making a claim.
At the same point here, I'm seeing now a side of the moon that is never seen. So I'll just illuminate it for you so that we can actually see a little bit. I'm now seeing a side of the moon that no one has ever seen from this land.
Yeah, but have you put the moon as a sphere?
I can make it whatever you want. I could make it that, but now it's no longer a circle in the sky.
Make it a concave moon.
In what way?
Concave, the same definition, unless you've got your own definition like you have for most things in science. Concave.
Okay.
For which direction?
Yeah. Just how do you want me to concave this?
Well, the first thing, right? Your claim is that you can't get it to match the observation of an
reality. Yeah.
Right, so we need to see what you're comparing that to be able to make that claim.
Oh, well, if you believe that we can see any other part of the moon other than this of what I'm looking at right now, give or take 5 degrees oscillation, then that's fine. I can bring up loads of Google images that say we only ever see this side.
What Dean is asking you, Riley, is do you feel that you can see more than 5% of any of the face of the moon that is always facing us?
I mean,
Well,
the
the
problem
answer's
is, Anthony, I mean, correct me if I'm wrong, but this moon at the moment moves around the equator. So we can see the sun, we can see the moon. Now,
yeah, that's correct.
yeah,
That isn't
correct, did you say?
That is not correct, no.
All right, so what do I need to do to make it correct?
You need to give it an elliptical orbit that oscillates around the Tropic of Cancer to the Tropic of Capricorn through the elliptical orbit on a tilt.
Okay, so how? So wait a minute, let me get my orbits up.
Right, so basically
We
what
can
you
do
need to
this.
do
Wait a minute. I can do this as you're telling. Right, what do you want me to do with these orbits?
make them into a circle.
They are a circle already.
Okay, but then make the center of that circle, which will be the North Pole.
Yep, it is.
Follow around a circle, a small circle around the North Pole to give it a cam, like it acts like a cam.
Oh yeah. No, I get it. Now that you said cam, yeah, that's not a problem. I can do that. And what's the oscillate? What's the factor on that? What? Because this is a day at the moment.
The diameter of the inner circle is the distance between the Tropic of Capricorn and the Tropic of Cancer.
Yeah, but what I'm saying is, what is the what's the period that this does 360? Is what I'm saying.
27.4 days.
Okay, no, that's cool. Because this is 1 day, so I can do this at 27.4 days. And what is the? Someone tell me the shift or radius of this circle, or what it would be.
It's the radius of the circle will be, well, the diameter of the circle will be the distance between the Tropic of Capricorn and the Tropic of Cancer.
Yeah, which is
I don't know.
46 degrees.
Yeah.
There.
It's what, sorry?
46 degrees
No,
in terms of.
Yeah, I want a radius, George, or a diameter, so that I can get a radius.
You need to know the distance between the Capricorn and the Cancer.
Yes.
Well, it'll be 46 degrees times 69 miles.
Not
7
as a
miles times 46.
You need to know it's a lateral mileage or kilometerage.
I'll tell you what.
For the equator, it's 10,000 kilometer, and let me get the answer.
Brilliant, awesome. Yeah. But while he's doing that, we'll say
3,243 miles.
Pardon?
3,423 miles. That's twice the Earth's tilt times 69 miles per degree.
Got it. So that was a radius, though, yeah. That was diameter. Yeah. So 150. This is 1 to 10 scale at the moment, so 150. So we're looking at about this. So if I say that this is here, and I'll make this rotate around in 27.3 day cycles in a second. But that now plants the moon here. So
yeah, that would be obviously in winter, wouldn't it?
Yeah. Now, but this is my logical problem now that you might be able to help me with. So I've got this moon cam, and if I'm looking from the Falkland Isles, something that you and I should both know well, then I've got a problem because I'm seeing a part of the moon that is never visible from this planet. However, if I am looking from the United Kingdom, I'm seeing about 10 degrees that is never visible from the entire planet. The only way that I can get this to work is it's currently locked in orientation to the North Pole. But I can make that locked anywhere that I want. And I can never get this to work because from different observers, I can see different areas of this big bastard moon.
Okay, I understand your point, and I see what your point the point that you are making.
Now I need help.
Well, all right. The equal and opposite point is that the chances of tidal locking caused by a cosmic explosion are 0. So which one do we go with?
I'm just on about visible observations here. I need to make this match reality, and I don't know how to at the moment. And I'm wanting to ask a prominent flat earther such as yourself.
Well, what I would suggest is that you've based this model on a spherical moon, and we know that the moon's not spherical because we all see the same face of it at all times.
Dean, can I say something?
Yeah, sure.
Anthony, the basic of this discussion is that Dean says that he's very good in AutoCAD and these applications, and he's ready to take any details that makes the flat Earth work. So he's not actually trying to debunk the flat Earth. He's asking you, how can you help him to enlighten him with data that can make the flat Earth work?
Well, for a start, the moon's not a sphere on the flat Earth model.
Okay, then what is it? Tell Dean.
I don't know what it is, but it doesn't display the attributes, the lighting
Oh, if you
attributes.
don't know what it is, then
It's
you
sphere,
have nothing.
because it doesn't have a central focal point of light. It only has a solid light, and then it diffuses away. It
All
doesn't
you have, Anthony, don't you realize all you have at this point is bullshit? You have no facts. You have no evidence. You have nothing. All you're saying, it isn't a sphere.
George, how can you say I've got bullshit when you weren't listening? Can you
I
see
am
how
listening. You have nothing. You've admitted you don't know what it is. You won't accept that it's a sphere, but you don't know what it is.
Dean, just put that back to a sphere for me, please.
Wait a minute, give me 2 seconds, because there's another problem with this that I'm going to show you in a second. Because the interesting thing about any of this is if I could make any shape out of it, but the only shape that matches the shading that we see is a sphere. Granted, wait a minute. Granted, I have not explored this option. So I will explore it, but but knowing this like I do, I pretty much know that, shading is not going to work on this. So are we saying it's kind of like this?
No, what I wanted to demonstrate at this point was that George's claim was...
I'm not bothered about George at the moment. He's a grumpy old man. So what do I need to do with... Sorry, George. Although it is true.
No, you're not.
I know I'm not. But it's socially acceptable to say. So is it kind of like this shape that I've got here? Is this what you're saying?
I don't know what shape the moon is, but what I can tell you is that the chances of tidal locking being the explanation for why we all see the same face of the moon.
I'm not on about probability, because 1 in a billion probability can still be probable and still be true. So I'm not bothered about probability.
1 in a billion is that's worse than 50 million to 1, and that's not probable either.
Wait a minute. It is within. It is. Wait a minute. Everybody, stop 2 seconds. It is, Anthony, if you do something a billion times. I'm really sorry, but I don't care about probability in this respect. I care about...
1 in a billion is not probable. I'm sorry, that's completely wrong.
I'm sorry. Wait a minute.
Somebody wins the Powerball.
No, stop. If someone on this planet has a chance of being born with a finger on their arm, and it's 1 in a billion, how many people on this planet have been born with a finger on their arm, on their forearm, let's say?
None, but that's not...
That's right, 180, because there are 180 billion lives that have cycled on this planet. So it's in fact very probable. But that's what I mean. I don't care about this probability. I care about getting some help on getting this to match a flat earther's reality. That's all I care about.
Dean, listen, I've got to go now, because that was my phone call to say set off.
All right.
I can do this another time.
No, that's cool. Yeah, that's cool.
All right, see you in a bit, bye.
All right, cheers, bye.
That fucking guy is all I'm gonna...
Well, what he does, of course, is he likes to mingle words and take words literally and conflate them into his narrative that he's trying to bring forth. This whole thing, like Rumpus was telling him, just because pressure has the word force in it doesn't make pressure force.
So he likes to make up his own reality.
Yeah, but guys, all I'm wanting for this is I'm wanting to find every flat Earth explanation for every aspect of this model to include every one of them, so that at the end of this I can just say...
You had him into a corner, and of course he wanted to disappear.
I don't know. I think he had to go pick someone up. I'm sure he would have stayed on.
Yeah, but he wasn't getting anywhere. You saw that. I mean, all he does is say, "All right, I know the moon isn't a sphere, but I can't tell you what it is. The reason why it doesn't work,
he says it's something.
You're assuming it's a sphere, but I don't know what it is."
He knew he was caught, so he went back to, oh, well, I'm going to go over to probability because I know probability means that it's not possible, and, oh, it's not this, it's not that, because if I make it anything, then obviously my bullshit will be debunked.
Yeah, he can be falsified in that case. But that's something that cannot be happening.
You just can't let him. You can't let him get away with this wordplay.
Yeah, but guys, my idea, my thing was not to. My goal in that circumstance is not to trip him up. It's actually to get every bit of information out that I can, so that I can amend this model, so that I can include his idea.
You weren't going to get there. Don't you see that? He was
I'm
telling
gonna tell you what
that was
happens.
our point, that he wasn't actually going to give you anything.
He was trying to tell you he could not tell you what shape or how to make the moon. He pulled this thing concave out of his ass. Well, what the
I'm
hell?
gonna tell the conclusion that happens.
Yeah, but George. Now I've got a concave moon that is going to be in this model that I can swap out really easy.
But you can do everything in your capability to fucking make the model as they say, and still in the end they are gonna say you did it wrong.
Yeah.
Even if you did exactly what they said, it was still you that made the mistakes.
But what he was doing, Dean, he was just pulling crap out of the air, throwing concave moon. Now, obviously, if you looked at concave moon and you moved off to the side, things would be totally distorted and totally different. I mean, he doesn't know what he's saying half the time. He just throws shit out there because he wants to get away from the fact that you've got him cornered.
Just throw everything at Dean and see if something sticks. That's the tactic. And he's gonna make you model everything out that he just can make up out of his mind.
Whether it makes sense or not, he's going to throw shit out there.
He's gonna ask for it.
No, wait a minute, George, Wolfgang, that's fine. I don't mind doing this because at the end of all of this, I will have got everybody's versions of their truth, though.
There's not gonna be an end. And if there's gonna be an end, the fault is gonna be on you because they don't make mistakes, of course, because they are perfect and the fucking smartest people on the earth.
Yes.
So it was you modeled it in wrong somehow, even if you did it just as they said you should.
I have a question though to the Globers in this panel.
Go ahead.
Why the famous statement of Anthony when he say, "Why do you deny science?" While in every science book that talk about fluids, there's the equation of buoyancy that identifying buoyancy is a force, and that what puts the tomato in the middle because the buoyant force down at the bottom of the tower is higher than the weight, and if it's go up, if you pull it up, it goes down because the buoyant force is less than the weight, and the buoyant force there's the gravity in it. Why don't you tell him stop denying science, because this is in science books?
Because he doesn't accept it. He just says it's a mathematical construct. And Schrodinger, you're roboted real hard again, man.
Yeah.
No. It doesn't matter what it is.
What he was saying is that we can't use math to describe reality. That's essentially what he's saying. And he's saying everything that we have, any explanation we have outside of the fact that he was changing the density is just mathematical and proves nothing. That's his
But it's in the science books.
Go ahead.
I said it's in the science books.
Yeah. But
Anthony doesn't
the
accept the
science book is wrong. Anthony is right, the book is wrong.
So he shouldn't come up with this phrase, "Why are you denying science?"
But
because
he has the
Just
scientific
because he
method.
shouldn't do it doesn't mean that he won't do it. He has his entire worldview based around the idea that he has specific knowledge that no one else has. The motherfucker thinks that the pyramids are Tesla coils.
See, the
you
thing
can just throw away logic and reason with Anthony. It just doesn't work. You can't reason with him.
Well, the thing that should be telling is he did not understand Archimedes' principle to begin with.
Yeah.
He asked you for a citation
based his
on
experience
the
on
principle.
that.
Yeah, but guys, I got something out of this. I got Anthony's reality out of it, and because I'm actually recording this for my YouTube channel in case anything cool was said, I'm going to show you what I got out of this conversation, and I'll ask. And Anthony will work with me, I'm pretty sure, in trying to make this a thing. But
I have my doubts.
The whole thing, Dean.
Are you ready? Wait a minute, George. Can you see my screen?
Yeah.
Anthony's reality. Cool, huh?
Yeah. But the.
Look at this.
But what it
No.
comes down
No,
to is
this
the fact that Anthony Riley does not understand a lot of the basic principles related to buoyancy, density, gravity, and he doesn't understand these things whatsoever. And he's just speaking from a position of total ignorance. The fact that he does not understand Archimedes' principle, which is just um, the very basic principle related to buoyancy and density, that an object placed in a medium will displace a weight of that medium equal to the weight of the object that's in that medium. But he was saying, well, an object will displace the amount of medium equal to the volume of the object, and that's not
Dean,
what it is. Because if that were the case, and if you dropped a cork into a pail of water, the cork would submerge itself totally, which it doesn't.
if you wanna see where he most likely got his concave moon thing out of, watch the video. It's from Pocket Word, and I posted it in the chat.
Nice. I'll have a look at this.
The plate moon,
It,
a dish,
uh,
like a dish.
it's concave cup moon, like
Yeah.
Cheerio cup. I don't know.
Yeah,
Just
and you
fucking
put it in
retarded,
water.
if I'm being honest.
Yeah, I mean, I did mention that the shading matches a sphere. You can hold a ping pong ball up when you see the moon, in the daytime, and it matches the shading exactly. I mean, for thousands of years, humankind has
If
been
you
able to hold up a rock and think, "Oh, hang about, this rock has got 3D depth to it. It's kind of round, and it matches the shading to that big thing in the sky."
if
Yeah,
you watch
Dean,
that video from 425, you can see how he means it should work, which
All
it
right,
doesn't,
yeah,
of course, but that's the kind of idea.
yeah, I'll have a look.
So
on this,
your concave moon is too shallow, I think.
Right, okay, yeah, the problem with that, though, is we're going to see. I mean,
It
on this
doesn't
flat
work.
Earth
That's
I'm
the
going to set it.
model,
Yeah,
problem.
I'm going to set it up
Dean,
like this. Yeah, this will be good.
Dean, on this flat Earth model that you're working on, the the basic fact remains that it doesn't matter what geometrical shape the moon takes, that if you're viewing it, the fact that it's a finite height above the earth around 3,000 miles or whatever, and if on this pizza plane of the earth it has say a diameter of 12,000 miles or whatever, there's always going to be two observers that are going to see two different things
George,
on that moon, no matter
George,
what the shape is.
George, I can't believe you just told a 16-year veteran geometric artist that. I really can't.
No, that's what you need to explain
No,
to
no,
Riley. It
no. You
doesn't
see,
matter.
that's coming from a negative standpoint. I'm wanting everybody's ideas in this to say, how does this work? And I'm wanting
Yeah,
them.
all you have to do is show him why that can't possibly be the case. He's got to come up. Why are you going through all these gyrations when you can just very easily show two different observers, say 90 degrees apart on the Earth, looking at a moon 3,000 miles above the Earth? You're going to see two different areas of the moon.
Yeah, I know.
The question is, how are you gonna make Riley understand that two persons cannot be watching that shape of a moon and see the same thing?
Well,
Oh,
I
I can
can.
Like,
actually answer
for
that
some
one.
reason, he doesn't accept that
You're
logic.
done at that point. There's no point jumping through any more hoops.
Well, you don't
It's
think
not for Riley though.
Yeah, you don't think that I'd. Yeah, it's not really for Riley. I'm wanting Riley to input into it. I'm wanting every flat earther to input into it. I want all of their explanations in this, so that we can all do a video and we can evaluate it based on the merits of it. I'm not even going to say we can
It's
pull it
just
apart.
funny how they are gonna come out and say, you didn't understand what they mean. So again, it's
I'll move on to
just
something more
surface
meaningful.
work.
That's my point. Why keep beating this damn thing about the
I say
moon?
it's good thing that he's doing it. I don't wanna say don't do it, but just know that there's always escape.
Mm.
Yeah, they'll find some wiggle room.
But I get the point. You're trying to solve at least one issue.
Yeah, I mean, if I can have a big dinner plate that solves 10 issues independently that can't work together, I'm all right with that. At least I'm building something where something's explained in a non-relative way. We know it breaks down with everything else, but this one thing could actually be a possibility. And like I said,
Thank you, Dean. I gotta get out of
Okay.
here. I just want positive people like you. Put the input in it. Think positive, Dean. Fuck George and his negativity. Thank you very much. I'm out of here.
see you later.
Okay, fine. But the problem becomes to the thing that they can say what it is and at the same time say what it is not. Like they don't know what it is, but they actually same time say that they know what it is.
Yeah, but
So they tell you one thing and then they can actually do at the same time say we don't know what it is. So that was just
no,
something.
I get that, Wolfgang, but just imagine, has anybody actually sat down, give them the time of day, like a geometric, a 3D artist, and said, well, explain to me, let's have a look at it? Because I'm pretty sure they won't have done this, and if they
Yeah, but
haven't...
it doesn't matter even if you do it like this. Like
Some people did.
No, okay.
Steve Torrance, have you checked his channel?
No, I haven't.
He's smart and he understands the globe, and he made a statement. Yes, and he made a statement that I usually use against flat earthers like Anthony. He said that the globe has a powerful what do you call it? A prediction, something like that, and he knows that we can predict the locate. Yeah, predictive power. We predict the star's location, the sun location based on globe geometry. But he says that there's another explanation, and he worked a lot with refraction and stuff like that. Just look up his channel, Steve Torrance.
Yeah, just look at this, just for everybody. I am actually having fun with this. I've actually now put in cloud layers, and in a real-time sense, I've put in little cloud shadows as well, so you can see that clouds are actually shadowing the, the Mexico here. And
by the way, what kind of PC you have to run this?
well, I've got a 24-core Mac Pro, but I've even got the clouds going off into this pressure gradient that goes to nothingness over the edge, over the Antarctic region. I was going to have it animated as well, falling over, but I just thought, oh, fuck it all.
Pretty close to perfection, like.
Okay, so you've put all this time into it. So what? What are you trying to show us here?
I'm just saying, I like it. I like the way that it's looking. It's
the best like one can come up and sort of that.
Yeah, this is their reality, George. I like looking at someone's reality. You look at people and
no, it is not their reality. They've never given us their reality.
That's their understanding of reality, I would say.
Yeah, their interpretation, their understanding of reality.
And not all flat earthers buy into this anyway.
Yeah, that's the greatest part. Like, I don't think there's a 10 flat earthers that agree on the model of Earth. And model is the wrong word in the beginning. Like, have you seen the Awakened Souls and what's the another guy? Who have the flat Earth map that has the Pac-Man.
Yeah, the Pac-Man, isn't Jaren kind of the Pac-Man sun advocate?
Yeah, it's the Gleason's projection with 4 poles and a Pac-Man sun.
That's just something unbelievable. Like, I have hard time. Like, sometimes there are flat earthers that I can actually understand that just lack the knowledge, but that is something that.
Yeah, it's so utterly ridiculous that you just can't even give it a second thought.
Dean, check the chat. I sent the Steve Torrance.
Yeah, thank you for that.
Cheers.
Well, Dean, I could buy into what you're doing if you approach it from this point of view. Just press Riley on getting the moon observations correct. And if you can't get it correct, you say, all right, we're done at this point. You can't make this one feature work. Therefore, nothing's going to work. or nothing isn't going to work, but all you have to do to disprove something is find one false
Not in their world.
aspect of it, and the whole thing is invalidated.
Yeah.
Anthony did found
say that
something
they don't
else in
know
the
what it
probe.
is yet, so
If it
it's
can't
impossible
predict
to
one
model.
observation, if it can't predict what we see for the moon, then the model is finished.
But
Yes,
this
Anthony
logic
did
doesn't work
found
with
that.
them.
He found that the eclipse should happen once a month.
Yeah.
Yeah, that I don't know why he said that. If he did, that'd be weird.
You didn't see the video?
No,
Oh my god!
I'm
he
not
thinks
as
that the sun, moon, and Earth are in the same plane, and so we should see an eclipse every month.
right. Okay. Well, even on a flat Earth, I don't get how that's a possibility.
No, he thinks our model says that. Let me rephrase that.
Oh, right. Okay.
Yeah, you could take it to one step further. If you allow yourself to be anywhere in 3D space outside the Earth, you can have a total eclipse every day, but not on the surface of the Earth.
I was gonna say, if I went on the dark side of the moon, I'm sorted.
Well, anyway, consider yourself lucky that he didn't say, "We don't know what the shape of the Earth is. It's just flat." So you did have something today.
But anyway, thank you guys for your input, and thank you again, Rumpus, if you're listening, for not getting me to go through with the Chris deleting his channel and all that kind of stuff.
You're welcome.
Yeah, good having you on, man.
I just get fed up with Anthony Riley's twisting and turning of words.
It's not even twisting and turning. It's quite literally failure to read the remaining 3 words in the sentence.
Exactly. Yeah, I mean, he picks out one word to focus on, and then it's pulls up dictionary definitions on that one word and tries to somehow shoehorn it into his narrative.
What definition has he done this on recently? Just now.
Facing
forces, pressure.
You're talking about the pressure thing. Okay, right back on that. Okay. Yeah. I've got a lot. When I have this hangout with Mike, I have to fill him 5 years of bloody education he should have had in the physics classes when he was a teenager. Deary me.
I'm glad he's one of yours.
Yeah, we could do without him, really, couldn't we? Yeah, it's a bit of a blight on us.
I don't really understand that. That's 7th grade physical science. How the fuck did he not get that?
Yeah, it's a bit incredible, isn't it? How, I mean, at 12, I mean, I don't know what you mean by 7th grade, but I'm certainly when I was about 11 or 12, probably, yeah.
It's 11 or 12, yeah.
Right. Yeah, you get told what pressure is, and when he has to go away and look at a definition and then think, oh, well, it's force, isn't it? I can see the word force. It says force there. It's a force.
Well, that's not half as bad as saying density is force.
Oh, God.
Well, I don't watch his videos anymore. I unsubbed after his pickle jar video. I even watch and sub to Anthony Sabrats and Mr. Thrive and Survive. I watch their videos and I make nice debunks for them, but because there's something that you can debunk. But his videos, no.
I'm trying to do a video actually on these last few videos, particularly they included a challenge to me about the jar and turning upside down and the burning of magnesium in a flask and then seeing the pressure reduction, which he claims is a density issue, of course. Yeah, I'm trying to do a compound video on all 4 of those videos, covering everything in that, but it's having to include some basic stuff, obviously, so that he'll understand it.
God be with you.
Unfortunately, I think what's happened here is the bullying and arrogance with which Quantum Eraser has bullied himself into Nathan's hangout has, just totally confused and side railed all the participants in that hangout, Riley included, and they don't know which way is up anymore.
Yeah. Yeah, well, that's right. And Quantum Eraser has actually given them some vague justification for some of their positions that they didn't have before, some sort of intellectual basis, even though it's obviously flawed. But they didn't have anything before. But now they've got things like experimental method and independent variable they can go back to, and God knows the other things.
Which they don't understand to begin with, but
exactly.
I missed the quantum eraser back in the day where you're like, well, look at the fossil record. And he's like, well, where's your independent variable of the fossil record? It was the dumbest fucking thing you've ever heard in your life.
Yeah, he's pretty dumb. I mean, he has now got a collection of quotes that he can go to. So he's got a library of quotes that he can leap to whenever you bring up a subject. He's always been quite good at that. And so that's his thing.
Well, he endeared us back in the day on ED 2.0. You know, we gave him the name independent variable.
That's
John.
right, independent variable John. Yes. Well, that was where I had that 2-hour hangout with him, and where I absolutely demolished him to the point where even his flattest friends in the Earth debate group were saying, "Shut up, John! You're talking bollocks. You've been thoroughly beaten," and he ran away, and he hasn't agreed to debate me ever since.
Well, he did try floating all this crap that he's given a soapbox on Nathan's. He tried this about 3 years ago, and it didn't float. Now, for some reason, Nathan is letting him do this, and so he's refloating all his old ideas, and now it's got some traction.
Yeah. When Nathan was desperate for some sort of scientific joke, because I think a part of it was actually myself and you were sort of throwing it's a science denier, reality denier, and now they're trying to embrace a bit of science as to fight that sort of accusation off. I mean, he does cite scientists, he does make scientific quotes from scientific websites and documentation and lectures and things. So obviously completely misquoting them, taking them out of context, etc., etc., etc. But nonetheless, he's doing that, which is more than they were doing before.
Yeah.
So, you know, I mean, that's from our point of view. It's obviously it's horrible to see these things being perverted, whereas at least before it was just opinion they offered, and now they pervert science, which is obviously even worse.
A lot of the newcomers here haven't seen the history that you and I have, Rumpus, and you even more than I, given quantum eraser. I mean, there's been a very marked deterioration in his presentation. Yeah, I think he's mentally degrading.
Yes.
He really is.
Yeah, they're getting more stupid, aren't they? Actually, yes, yeah. They've learned some more. They improved the tricks they can play and debating ploys they can use. They've got a bigger armory than they did before, but they seem to be getting more stupid as they embrace it all more.
But with quantum eraser, I mean, there is something going on there, and I think truly he has some mental deterioration going because he's so much more forceful and arrogant and screaming and yelling now than he did a year or two ago.
Yeah, that's because he's more confident. Yes.
Yeah, it's also the attention and the applause he gets from the flat earthers. Like the more arrogant he is and the more bashing he deals out, the more like attention and like praise he gets.
Yep, definitely. Yeah, he's now been instilled with, because Nathan's given him a platform. I mean, Quantum Racer doesn't have any videos of his own, and because Nathan's obviously boosted him, he's obviously got more cocky with it.
Yeah, and Nathan is backing him up all the time. Like even if he were losing, which would be all the time if we were honest, but like Nathan will be shouting over the opponent and giving him unfair advantage, which should be expected, of course.
Yeah, I think he's naturally inclined. I mean, even the debate that I had, he was always a shouty interrupter, even from 2 or 3 years ago, and he's just simply now got some. He's even more abusive, and it's followed a path, and he's just become more of what he was before. So it's not as though Nathan's created a new monster. He was already that monster, and just simply given him a slight amplification.
Yeah.
And if you have seen his older posts at some forums where he debated like young Earth creationism or something like that, yeah, he was pretty abusive even back then.
Oh right, okay. I haven't seen those. What forums were they?
I don't remember the actual forums, but
Right,
I don't think it's very hard to find out actually.
It's just a long time ago, but he used to do literally the exact same script about independent variables, about fossil records, about evolutionary biology. It's the same shit. Like, I don't even pay attention to him because it's literally the same shit.
Yeah, this is why George was saying we used to call him John Independent Variable when he first brought this up, and we all had to go. It made us go and check though about scientific experiments and dependent variable. But even people who knew quite a lot about science, because scientists don't tend to think of it in those terms. They do if they're forced to, but they just know what they're doing and they just have intuitively understanding they need to vary this, and the other comes to that they might forget the names. And I was obviously aware that's what you do, but I couldn't quite remember the names. And so he forced us to go and remember what it is and examine the experiment. But basically, basically the model he uses as a sort of scientific method for kiddies. We'll find your phenomenon. That's tick 1, then do the tick 2. And then if you basically look how scientists work, they say basically science is what scientists do. Ultimately, what happens. There are many millions of ways of different.
Experimental scientific method.
Yeah, there's lots of ways of
doing
it.
I've heard.
There's no simple formula like the one, and it's wrong anyway.
Yeah.
Many things don't start off with the phenomenon. Things like the Higgs boson, they didn't start off with the phenomenon.
That's the fucking most annoying point. Is like, what's the natural phenomenon? Like, goddamn.
Exactly.
It's the
on the flow
mass
chart.
attracting mass, and where do we see that in nature? Fucking everywhere. But no. Well.
Indeed. Anyway, I've got to go for a little bit of a walk and go shopping.
Yeah.
So I'll speak to you.
It was nice listening. Once again, I didn't take that much of a part.
Wolfgang, where are you from?
Finland.
Finland. Oh, okay. So, what's that thumbnail? That your image? What is it about? The man with the cross.
Oh, it's just something. It's a part of a picture from my favorite album.
Oh, which album is that?
It's from P-Hexen, My Soul for His Glory.
No, I don't know it.
It's very underground. But no, well, not that underground, but still pretty niche genre of black metal.
Yeah, I love metal of North Europe. Yeah, it's very
best
hard.
metal around, of course.
Yeah. All right, so I think I gotta go now.
Well, this might be a good time to bring something up. Khaled and I have been talking a little bit about possibly starting a channel where we can have reasonable discussions on scientific matters and not allowing introduction of this flat earth nonsense or anything. So if any of you might be interested in this sort of thing, think about it. Is what we would need is probably several hosts, because I wouldn't be able to do this every day, and need other people to help share hosting. If we wanted to do this every day, maybe have 4, 5, 6 different hosts, one each having a day in which they would monitor and oversee the show.
I can oversee the show, but of course, I don't hold any scientific degrees. So, like, if someone asks me what's entropy, I don't know.
No, that's okay. I mean, what we're saying is, people have certain talents in different areas. I like to learn. I like to hear about different subjects, not only just related based in having to do with gravity or hard science or anything. Maybe you have some new technique for overhauling an automobile engine or something, or we can discuss various or topics in the news having to do with new technology or science or something in news. It's just a thought. I mean, just to get away from all these shit shows that seem to be popping up now.
Yes, I would love to, because I'm sick of this flat Earth. But people are talking. Some people bring good things among all of the shit that we are seeing, and I'm just fishing for all the nice things that I can learn. But instead of that, if we have just a pure science, a pure educating, that would be beautiful.
Yeah, and if you want to, get your daily dose of flat Earth, there's plenty of other channels to go to. I'm talking about having a channel where there's going to be reasonable people having reasonable discussions that you can go to for relief if you want it.
Yes.
Because my days are numbered here too. I was rather surprised at Jose's comment when he left about me being so negative. All I try to do is just cut to the chase. I get tired of hearing the same thing massage and bat it around hour after hour.
Actually, I think
Jose likes to revel in the idea that everything that happens in the show can easily turn into a fight, and he doesn't like it when people try to slow things down, and then he tries to inflame it by picking at people. Like, is it like you, George?
Yeah, well, that's what I say. I mean, that's fine. That's what Jose wants. He wants dumpster fires. Fine. It's just not for me, and so I won't be probably showing up very often because I can see that. I mean, that's been his attitude here lately.
So I do wish the Flat Earth. Oh, go ahead.
I was saying, George, you said that you look into some things and you might have some plan to make this thing work.
Pardon?
You said that you might be looking into some things to make this kind of channel, and I hope you're keeping us update on if there's anything we can do.
I mean, in the as as I think more about this going forward is I'll post it in the Skype chat in the open discussions there. Something that is kind of throwing a wrench into the works for me right now is I was approached again by this one group in Germany that I've been talking to over months that looks like they want me to do consulting work and bring me over to Germany to work for a while. So until I get that figured out, I have to kind of put this thing, at least for me, starting it on hold. I'd be willing to fund it if that's what we need. I would feel that to have any sort of open discussion group like that is to do what Jose is doing and using Google Meet, where we can have total control on who is allowed into the Hangout, because I know there are people out there that absolutely hate me, like PMARS and a few others that would constantly try to bring the Hangout down. So we need to have some sort of a line of protection that something like Google Meets allows us to have. So if it's, but would he say it was about $12 a month or something, I could easily, foot that bill for the rest of us, and to have that level of protection.
I like the concept for a show that's just a bunch of easy chat and science going, but easygoing science chat. Good Lord, I cannot English today. Jesus.
Yeah, I mean, we could start it off with 1 day a week and see if it isn't going to be a constant thing like hours a day every day, like with Jose and these others. I mean, we'd run out of topics quickly. And I just don't want to have an endless discussion on the same topic over and over and over.
You should actually reach out to MC Toon. He could really give you a hand with that.
With who?
MC Toon.
I don't know who that is.
He does a lot of pseudoscience debunking. He got really caught up with Flat Earth because he was the first person to answer Flat Out Heroes challenge.
Well, again, I'm not looking to have another channel to address flat Earth topics.
No, he does.
If somebody wants to cloak it into a question on science, that's fine. If you can,
Oh no, I'm just telling you that's where I met him, is through that. But he has a scientific mind, and he can go through just about anything with you. He's a smart guy. He'd be good to have on. I think he's actually a software engineer.
Well, again, that's where if once this thing got started, then someone like yourself could invite others in that might have interest or a topic to share with others. That's what I would be looking for, is for us to reach out to the community out there, scientific community, engineering community, and bring people in to maybe discuss what they're working on or something of interest to them.
And maybe
Yeah,
Dean
I could
can.
absolutely. Go ahead. Sorry.
Sorry, I said maybe in one of these episodes we can have Dean explain how to work on like Blender or some things like that.
Yeah, exactly. You know, uh, draw on the expertise of others. I mean, Dean obviously is very good with 3D graphics and that, and you know, of which I haven't worked with at all, and I find such of interest. And we could also bring in. I don't know. Many of you know of Kara. She used to be on ED 2.0, and she's very excellent in using Unity. She builds models using Unity. She's a works in a machine shop. She does all the programming of their pneumatic mills and lathes and stuff. So she's real good with modeling also, but uses a different platform. She uses Unity. So yeah, there's a lot of people out there with different expertise that we could bring in to talk about what they do, you know.
No, absolutely agree there. I'll stay in touch about that on the Skype channel. I've actually got to run, so I'll catch y'all later.
Yep. Take care there.
All right, take care.
Yeah, I don't know. You know, this whole thing with Riley, I just find rather amusing listening to how he loves to dance around words and keeps everybody dancing.
Oh, I cannot tolerate that. Really, it pissed me off.
Yeah.
So, you know, few years ago, I've been asking myself a question. You know, the mercury barometer.
The
When,
what? Oh,
the me-
mercury barometer.
barometer, yeah,
Uh
yeah.
huh.
If you fill the tube with mercury and then you raise it up from the container, at a certain point, the mercury will not rise with the tube.
Right. Yeah, it's around 30 inches.
Yeah, and if you pull it more, if you pull it, so at that point there was vacuum on the top of the mercury.
Well, yeah, in a sense, what you have actually in there is partial pressure of mercury. You've got mercury vapor in there, but yeah,
Oh my God,
essentially a
that
vacuum.
yeah, I've been this question been driving me crazy for 3 days. Sorry, for 3 years. Sorry, I'm just a bit excited. And just recently, I found this out that it's mercury vapor because the actually it came to my mind when I was looking into someone said the saliva of the astronaut who is testing the vacuum chamber was boiling, and I went to check the boiling temperature, and I said, okay, let's check mercury, and I found out that on low pressure it's minus something like that, or can't remember, but yeah, at that point I got it. So there's a lot of us who has questions, but maybe the questions are long buried, and then they come out when they see a good discussion. So this is the one of the things that I wanted to share with others
Uh huh.
when this show. It's nothing new. I'm not going to be pointing to something new, but I point to something that people could have asked about, like I myself did.
You know, this brings to mind a point. You know, like in Riley's experiment where or demonstration where he had the jar turned upside down and have the water held in the jar by having a a barrier, a lid or some a piece of paper at the open lid of the jar, and um, and the you end up with what we call vacuum up at the top, which is nothing more than really it's water vapor at the partial pressure of the water vapor at that temperature. And so it's not a real true vacuum in there at all, or even a near vacuum, because there's water vapor in there, and the amount of water vapor and the pressure in there will be the partial pressure of water at that given temperature. So I bet
And
if you took
yep,
like
yeah,
a torch or whatever, and you have that sitting up, you know, you have the jar upside down with the air pressure holding the water in the jar. I bet if you took a torch and heated up
yes,
the top side, that vapor pressure is going to increase to a point where it's going to eventually get very close to the atmospheric pressure, and then the water should drop out.
well, actually, I was thinking of doing that same experiment, but I was looking for, I mean, the thing that you're saying right now, but in an opposite way. I was thinking about doing it, but I was looking for the proper kind of glass. Initially, I would put boiling water in that. I will bring a bottle, not a big container like this. I put boiled water in it, leave it for a couple of minutes, and then pour away the water. So the glass will be hot, and so the air will be hot. And then I do this the same experiment and leave it. And uh, sorry, but it's also it depends
Well, what
the
you
same
could do
recipe.
here, Khaled, what you could do is you could take that flask, heat it up, in a Bunsen burner or whatever, put a little water in it and get that water boiling so that there's really hot water vapor in most of the flask, and then pour out the water and very quickly take the flask and immerse its open end down into some water and then let it cool, and you should see it suck up the water eventually.
Yes, yes, yes.
And have them explain that using their density.
And when we were kids, we used to do this with a candle.
Yeah, exactly. Yeah. And I asked Riley in one of the videos, I posed a question to him. I said, here's a simple demonstration that's always shown to children. We've shown to children. You take a metal can, you put some water in it, you boil it, you get it boiling, and then you cap the can and let it cool down, and you see that the air pressure crushes the can eventually. Now explain that using your relative density concept, you know.
Of course, he gave you some word salad.
No, he never responded at all. I should have asked. I should have remembered to ask him that in this hangout. But next time you people, any of you happen to get in a hangout with him, ask him to answer that question for me. How does he
Yeah.
explain the crushing of a can with his relative buoyancy explanation? Because there's no mass change. Once you cap the can, the mass inside the can stays the same. So as a can is crushing, the average density inside the can is increasing, right? Because the volume
Yeah.
is decreasing and mass remains constant. So shouldn't that be opposite of what he's claiming? you know, as how is it that the density is increasing as the can is crushing? How is it
Yes.
how is it that the
Uh,
relative density inside the can is increasing?
but then he will ask you define pressure, and then he will go on Wikipedia.
Yeah, exactly. Yeah, it's an endless
It's
circle
it's a
with
hopeless
these
case.
guys.
Yeah, hopeless case. And sometimes uh, I'm sure that Anthony Riley knows that everything falls at a rate of 9.8 meter per second square if there's no air resistance. I'm sure that he knows that. But when he senses that the conversation is going to use that concept to debunk him, then he says, "Okay, where's the citation? What's the proof?
Oh,
Real life proof?"
yeah, that's their
Did you?
fallback position. That's how they can derail. They found that will derail a conversation instantly the minute you start demanding citations. Just like this thing, I said talking about Archimedes' principle when I corrected him as to what the Archimedes principle. What was his response? Show me the citation.
Yeah. There was a hangout on channel Q a few weeks ago, and it was also this issue of buoyancy. The egg after his egg video, and I told him that the force that make the egg go up is not only the density, because it's the buoyant force. And he said, "What's the buoyant force? How can you claim there's such a force?" I said, "Buoyant force is the density multiply the volume displaced multiplied by g." And he said, "Show me this."
Yeah.
And I
Well,
said,
the
"Oh my
thing is,
god."
well, what happens, the wall that you hit with a lot of these um, people from Nathan's show, and I keep telling them this, is I say, you don't prove a definition. you know, um, you don't prove the radius of the Earth or the radius of a sphere. That's a definition. You don't prove
Oh my god.
definitions.
Yeah, this is very stupid. A proof of R. What
Yeah,
the fuck is that?
yeah, exactly. Yeah, you don't prove definitions. Definitions are. You just accept them because that is how we define a particular concept. You don't prove it. It's a definition. You don't prove definitions.
Or he may ask, how do you conclude the R? How do you calculate the R? But not how to prove the R. This is the question is wrong.
Yeah.
And even worse than this is the famous phrase, vacuum next to pressure. And the worst thing about this is us, the Globers, who
Well, they should never bought
amuse
into
him.
it in the first place. There is no gas pressure next to a vacuum. Never
Well,
has been.
well, that's the point. We should. I mean, the first time this statement came up, someone should have asked three questions: define vacuum, define pressure, and define next. What do you mean by these three? So
But
if next he say,
yeah, I mean, you don't have that. You never have that. There, even with the Earth's atmosphere, that's not the case. And then they say, well, where is the container? And what I brought up here lately to them, and they haven't answered, is I just tell them, well, you obviously don't understand the concept of some central force as there is with the Earth. They're always ignoring the properties of a central force. A central force is if you have a collection of matter, whether it be gas, molecules, or whatever, if you have a central force present, then the gas molecules or elements of matter, bits of matter, or whatever, will collect in a sphere. And
yeah,
that's what you have around the Earth. If there wasn't the landmass of the Earth, all of the atmosphere would be basically a spherical gaseous ball. And that's what you kind of have like with Jupiter and Saturn.
yeah,
Um, and the fact that we have a material basis to the Earth, rock and all that, is that this gaseous material stops at the surface of the Earth, but it still is forming a sphere around the surface of the Earth. And that's because of the fact that there's a central force present. That is a consequence of having a central force. And they never ever bring that up, or I doubt that they even realize that.
well, they reject gravity, so they will reject that concept.
Right. Of course. Of
But
course.
but but again, even in by observation, if the Earth is flat, we climb up, the pressure reduces, so at some point it will be virtually zero. I mean, how hard is that?
Right. Yeah. That's been my point all along, is that the gradient of air reduces as you get up above the surface. The higher you raise yourself up above the surface, the thinner the air gets, the less dense it is, and it eventually feathers and merges into what we call the vacuum of space, or the near vacuum of space.
Yeah.
It's just a gradual merging. There is no hard line of demarcation between what we call atmosphere and what we call um, the near vacuum of space. That it's an arbitrary definition. You, you select what you want the pressure to be at that uh, what you define as the near vacuum of space, then that will tell you at what point at the height above the Earth the atmosphere ends and the near vacuum of space begins. And arbitrarily, we've essentially chosen that to be the Kármán line, which is a nice number. It's 100,000 meters above the surface of the Earth. It's just been arbitrarily chosen as that, is that the air pressure is sufficiently reduced, sufficiently small as to be considering it the near vacuum of space, and it works out to a nice number, 100,000 kilometers.
100 kilometer.
100,000 meters, I mean.
Yeah,
100
yeah.
kilometers, yeah.
I was surprised following some channels like Scott Manley. He mentioned something about orbit decay, and he mentioned that even up to 300 kilometer, there's some gases that reduce
Yeah, of course, yeah. The ISS has to
Yeah,
periodically be boosted back into orbit. Its orbit continuously decays. And they have to fire some rockets, retro rockets, to boost it back into a higher orbit. Otherwise, it would eventually decay to a point where the air starts becoming dense enough where it causes sufficient drag, where it would just probably be a matter of hours before it really dropped significantly out of orbit and started being like a meteor and getting burnt up in the atmosphere.
Yeah. Did you try any of these simulators games like Kerbal Space
No,
Program?
no.
They are beautiful. I got one. It's a little bit cheaper and simpler and better for my slow machine. It's called Simple Rockets, and
Uh-huh.
I learned a lot of things from it. Uh, I even used it in some videos explaining some things like the orbit of the moon, because there was an understanding for me at least that the orbit of the moon is you know uh, it's an ellipse, and I thought that the apogee is maybe high above the ecliptic, and the perigee is low below the ecliptic. But
Yes.
then, uh, but but then I found something that is called ang- uh, the argument of periapsis. Argument of periapsis, which means how far the perigee is from the ascending node.
Hmm.
And when I looked deeper, I found out that the perigee of the moon changed its location on the same plan of the orbit, until sometimes the perigee is on the ascending node, where that happens. They like the the uh, the eclipse where the moon is closest to the Earth, and we have annular eclipse and something like that. So I tried all these things were with simple rockets too. It's beautiful. If you get a chance, you should try this. It's very beautiful.
Yeah. Well, these simulation programs, if accurately done, can be useful in helping you understand the nature of orbits and how things uh, interact, how masses interact in space. No doubt.
Do you have any knowledge with ellipses as geometry?
Oh yeah. My first video that I produced, if you want to go, I talk about ellipses for about the first half hour of the video, properties of ellipses and how to derive the equation of an ellipse, and talk about the eccentricity in the area and perimeter of ellipse and the
Yeah,
properties.
yeah. I will sure go and check that. Because um, at some point I wanted to know where would be the Earth in relation to the Sun at a certain date,
Well, if you
and
want that, there's a very good site called heavensabove.com. It's heavens-above.com, and it gives you the parameters daily on all the positions of the planets and their distances from the sun.
Oh no, no! I wanted to know to do the equation in Excel for my sun calculator. So it's not that I want
Well,
to
I mean,
know.
you can get it to a gross approximation. There's so many to get it accurate. It's virtually impossible to get a closed form equation because that falls under what we call the three body problem. You cannot in closed form describe the motion of three masses acting in space given initial conditions. It's absolutely impossible to do. You have to use numerical techniques to solve the equations. You cannot express it in closed form.
So the Earth position in relation to the sun, this is affected by the moon.
Yes, very much so.
Oh my God! You know, oh, I didn't know that. I thought the problem is with calculating the moon orbit, not the Earth orbit.
No, in fact, the Earth's orbit also affects the position of the sun slightly.
Oh, wow. Well,
Yeah, go to my first video. I talk about that, solving,
yeah, I
deriving
will.
Kepler's third law. It's called Flat Earth uh, Answers and Explanations. It's about a
Mm-hmm.
2-hour video or so, and I talk about Brian Mullen and how he botched up calculating or deriving Kepler's third law, and showed the proper way of going about doing it, and talked about centers of masses, moments of mass, and all that, and how you go about doing these sorts of things. But to get, I mean, you can get it to a first order, just using the sun and the earth and neglecting the effects of the moon. You can get the Earth's orbit pretty close, but if you wanted to try to get it with any sort of accuracy, you just can't do it in closed form. It because you have to introduce the third body, and that falls under, like I said, what we call the three body problem, which cannot be solved in closed form solution.
What does it mean in closed form
Oh,
solution?
to
What?
express, say you want to know the position, say you put our position in you're familiar with polar coordinates, like
Uh,
versus rectangular coordinates. You'll have x, y, z coordinates from a point of origin, whereas in polar coordinates you have a radial distance out and an angle.
oh, okay, yes.
Or you can, or just say in terms of rectangular coordinates, x, y, and z, with respect
Okay.
to a origin. Say you put your origin at the center of the sun, and you want to express the Earth's orbit. X is a function of time, Y is a function of time, Z is a function of time, its position, the
Yes.
Earth's orbit about the sun, its position at any given time.
Yeah.
Well, it, if you specify initial conditions, where the Earth is at time equals 0, what its velocity is, what its position is, with just the Earth and the sun, and using Newton's law of gravitation, you can get X, Y, and Z as a function of time precisely, as a function of your initial conditions, the initial velocity of the Earth and its initial position. But if you introduce a third body like the moon, you cannot do that. You cannot express the position of the Earth as a function of time in terms of what we call elementary functions, that is, polynomials, trig functions, hyperbolic functions. These are your elementary functions. You cannot express x as a function of t, y as a function of t, or z as a function of t in terms of these elementary functions, given initial conditions if you have three or more bodies introduced into the problem. You have to solve it numerically or use special functions to describe the motion. Special functions would be functions like hypergeometrics, elliptic integrals, Bessel functions, Legendre polynomials, things like that are what we call a class of special functions, whereas the elementary functions are polynomials, like x squared, y squared, x cubed, that sort of thing, sine trigonometric functions, sine, cosine, tangent, or hyperbolic functions, hyperbolic tangent, hyperbolic sine, that sort of thing. These are what we call our elementary functions, and you cannot express the trajectory of bodies under the influence of gravity when you have three or more bodies introduced into the problem. Can't be done.
No, I came up with an equation, and of course it's wrong, and I realized it's wrong when I tried to apply it to the moon orbit. Um, and I use this equation in my sine calculator, and I get like a lack of accuracy of like 0.1 degree in the sun azimuth. Sorry, the sun elevation at noon. What I did was I presumed that as the Earth covers equal areas around uh, the sun focus, it covers equal angles around the empty focus. Of course, that is wrong, but because the eccentricity is very small, so this approximated things enough
Yeah.
to work.
Well, like I'm saying, you can get approximate trajectories for orbits and stuff. If you're not trying to be too fussy about accuracy in that, you can do these things in closed form. They become, approximations to the actual reality of the situation. And sometimes that's good enough. But if you're trying to get to a high degree of accuracy, then you can't do it that way.
So, how much lack of accuracy happens if we do the calculation with the one body only, the Earth and the Sun, and if
Well,
we
I don't
put
know.
it,
I've never really looked at it. I don't know what the degree of error would be. It probably wouldn't surprise me if you could probably maybe do no better than 1% or maybe a tenth of a percent. I really don't know because I haven't really looked at it. But if you use uh, the concept of a central force, and this is what Newton did, and showed that the orbits of planets about the sun are not circular but elliptical. And of course, with the Earth, the eccentricity of the Earth's elliptical orbit about the sun is very, very small. It's 0.0167, which tells us that the Earth's ellipse is not squashed. It's squashed very, very tiny from a perfect sphere or
yeah,
perfect circle.
circle, yeah,
And so you wouldn't be able to draw the difference on a standard sheet of notebook paper, the difference in the Earth's elliptical orbit from a true circle, because the width of your pencil or your pen would more than swamp out the difference in the elliptical shape from the perfect circle shape with an eccentricity of 0.167.
yes.
You just can't do it. So, for all practical purposes, the Earth's orbit about the sun is near perfect circle. Good, because if you look at the true focus point, the center of the ellipse, the Earth's elliptical orbit has uh, in the elliptical model, the sun is at one of the foci of the ellipse. The ellipse has two foci. So
Yeah.
the sun will be at one ellipse or at one focus, and then the Earth will be around it. Well, if you look at how much the focus is offset from the center of the ellipse, that comes out, I can't remember the exact number, but it was, I believe it was less than 1,000 kilometers. It was only like, maybe even 20 kilometers. I don't remember what it was when I calculated. I talked about it in my video.
Hold on, take your time. Take your time. Drink a cup
But
of
the
water.
thing
I'm
is,
here.
like, given the diameter of the sun as being around 800,000 miles across, let's see, 800,000, 5/8 of that. Let's say about somewhere around 500,000 kilometers for the center of or for the focus of the elliptical orbit to be offset from the center of the sun by on the order of, even 1,000 kilometers is negligible.
I think it's more because the apogee is 152 in kilometers, and the perigee is 147, I think.
Yeah. Well, the way you get
147
that is
billions.
you take the semi-major axis, call it A, which would be the mean radial distance of the Earth's orbit about the sun, which for most, excuse me,
Take your time.
yeah, we take as the mean orbital radius of the Earth about the sun is 1 astronomical unit, and that has an official definition. It's it's an exact number. Okay, so if you want the apogee and the perigee, if you know the eccentricity, call it little e, and for the case of the Earth's orbits, that's 0.0167. So your apogee, which is the furthest point from the sun, that's 1 plus e times your semi-major radius, which is the astronomical unit. So take an astronomical unit, multiply it by 1.0167. That gives you the apogee, and the perigee is 1 minus that. So it would be the astronomical unit times 1 minus 0.0167. That should get you real close to what the apogee and the perigees are.
Mm-hmm.
From property of an ellipse.
Yeah, I always get confused with the calculations of the eccentricity. I have to always, every time I have to do something with it, I must
Well,
go back.
eccentricity, the eccentricity squared is 1 minus b over a squared. 1 minus the quantity b over a squared, where b is a semi-minor axis and a is a semi-major axis. So the eccentricity is the square root of 1 minus the quantity b over a squared. That's the definition of eccentricity.
It has many definitions or many ways to calculate it. That's why I'm always confused.
Well, when b over a is well, b and a are very nearly equal to one another. In the case of for a circular orbit, b equals a, and in the case of the Earth, it's they're very nearly equal because the eccentricity is such a small number. But you totally describe an ellipse, you only need 2 numbers, the eccentricity and the semi-major axis, and that totally defines an ellipse for you.
Yeah, solves everything with the proper equations, of course.
Yeah. Well, you can derive everything else from those 2 numbers by knowing the eccentricity and the semi-major axis. You can get where the center of the ellipse is. You can get the semi-minor axis. You can get the perimeter of the ellipse. You can get the area within the ellipse. Everything follows just from those 2 numbers. But yeah, go to my channel if you want and look under the very first video I ever produced called Flat Earth Answers and Explanations. And I talk about ellipses for about a half an hour, I think. The properties of ellipses and how to derive all the parameters.
Yeah, I need to see that. All right, I think I'll be going now. I can never
Yeah.
have enough talking to you. I enjoy it a lot. And
All
you
right.
know,
You're welcome.
when you're
I
not
always
here,
enjoy
there's a lot of things I want to ask you, but when we're here, I just forget.
yeah. Well, write it down.
Yeah, exactly. That's what I need to do. And now I'm officially retired, so I'll be having more time.
Oh, okay. All right, good.
Yeah, yeah. Thank you. Okay.
Yeah,
You have
I'll
a
be
good day.
happy to help you out with anything that you want. I enjoy talking to people that like to learn,
Yes. Thank you a lot.
unlike these
Okay.
flat earthers that couldn't care. They could
Oh
not
my.
care less.
That reminds me. Do you remember when one time I said I sorry? I think I have a phone call. I'll
Okay.
just check it and come. Sorry, hold on. Hello?
Yeah, I'm here.
Yeah, I'm sorry for that. Do you remember when one time I said I have an idea to produce thrusts without thrusting matter?
Must have been talking to someone else, not
No,
me.
it was you on that channel. What was its name? Earth Discussion, I think.
Well, that had to have
Er,
been a long time ago.
Yeah, yeah, it was. And I was showing a a balloon in a like container of water, and when you release that balloon was pulling on the container upward, but now that pulling is not there. The water level is still high, so we calculate the pressure at the bottom of the container, and we get an extra fake downward force on the container because the water level is
That was you. I
yeah,
kind of remember that. Oh God, that was a long time ago. That was a year and a
yeah,
half or so ago.
yeah. I think so. It was when I first joined the Flat Earth and I saw
Just
this
a minute.
channel.
I think I kept your diagram someplace. I got to remember where I put it. Hmm.
It has a balloon and a brick tied with the balloon, something like that.
Yeah,
So
hang on a sec. Yeah, go ahead. Keep speaking. I'll see if I can find this.
yeah, later I looked into it again and I found, and well, I debunked myself also, even though you already debunked me at that time. But the point I want to say is that I was aware that I'm doing something that is supposed to be against science, and so I went to people to ask them, just help me look into it. Maybe it works. Maybe there's some kind of backdoor for science, and I learned. I mean, I don't argue. I'm not. I don't know how those people think. They talk to people that I mean, like you, that they are knowledgeable. They know a lot, but they don't take anything. They're not learning anything. So it's okay to come up with crazy idea and discuss it with people, but open your mind, same as I open my mind for the craziness, I open my mind for the righteousness. So I don't know how they think. Really, it's disappointing.
Wait, that's yeah. Gosh, I see the diagram in my mind, and I've got so darn much stuff. I'm not sure where I would have stuffed that. Shoot.
That it was long ago. I mean, I have things that I had like a couple of months ago, and I can find it.
I'm trying to come up with a name I would have given it so I could do a search for it.
Maybe Crocs or MDF, momentarily displacement force. That's what I called it.
Yeah, no, I would have called it something different. Shoot. Let me think. Hmm. Oh, my. Ah, unbalanced energy wheel. I bet that's it.
It wasn't about free energy. It was about thrust.
Oh, well, then you're not the person I thought about. Here it is. The one I'm thinking of. It shows a 2 for. Oh, come on. Let me do a share here and see if you recognize if this came from you or not.
Okay.
Let's see. Bring up the hangout here. Shoot. Okay, present now. Entire screen. Okay, see if this. Tell me when my window comes up for you.
I can see your icon still,
Okay.
but not your.
Oh.
Do I need to
Oh
click?
wait, here we go. Share. Okay, here we go.
Yes, I'm starting to see.
You got me now,
George. No, still. I think it's still sharing. Oh, I see.
You see my mouse moving around?
Yeah, I see your.
Okay. Let's see here. This is the one I'm thinking about. Was this from
Oh
you?
yes, this is also from me. I also looked into free energy.
Oh, okay.
Yeah.
All right.
So
yeah, that's what I was talking about. That's the only one I remember from you. I don't remember anything about thrust.
Yeah.
Okay.
So
see, I'm not so senile after all.
No, you're great. So my point or my position when I started looking into these things maybe 12 years ago, there is no conspiracy. The oil companies are not holding the secrets of free energy in order to get millions and billions. That's not was my thinking. I was thinking maybe there's something that someone didn't notice, and that's how I started working. And I started at first I started by looking into magnets, but then I realized magnets is very hard to work with. I have to imagine or simulate the flux line. You call it the flux line?
Mm-hmm. Well, the thing to remember about this whole concept of trying to extract energy out of a magnetic field, particularly a static magnetic field, yes, there's energy present there, but you can't extract it. The only thing that can be done is a static magnetic field can allow you to convert one form of energy to another. Hence, like a generator where you put mechanical motion in to turning the armature, and the coil windings of the wire, copper windings of the armature cut magnetic field lines. So what you're doing is converting mechanical energy input into the system into electrical energy. All you can do is use it to help you to transform one form of energy to another, but you can't extract energy out of the field.
Yeah, okay, I want to show you something about this free energy.
Because if that were the case, say if you had a permanent magnet generator,
Yeah,
then wouldn't you think eventually you'd deplete the magnetic field of the permanent magnets?
I wondered about that, but I'm not sure what happens eventually.
So, you know, it basically comes down to thermodynamic systems. The conservation of energy is that you cannot create or extract energy out of any sort of a energy field without first inputting some energy in, you know, to that field can be used to convert excuse me, forms of energy, but you just can't extract energy out of the field because, you know, given Einstein's equivalent principle, that mass and energy can be thought of as being manifestations of the same thing. If you're going to start extracting energy out of a field, eventually either some mass has got to be converted or something's got to be going on there, and that's just not going to happen. You know,
Something gotta give. So, anyway, I left the magnets thing and I went into water, gravity, buoyancy, and I came up with beautiful designs that took me a few weeks to debunk them because I usually make a design and be happy with it, and then I that maybe I'm just happy and I'm not looking at why it wouldn't work. But for 12 years, I'm telling you, I made like 7 or 8 designs for free energy and I debunked all of them. So
yeah,
that,
yeah.
that's
You
how,
mentioned that to me once in a comment section, I think it was,
yeah.
or in the Skype chat. Yeah.
Yeah. So, but there's something still in my mind regarding magnets because it's complicated, and when things are complicated, uh, and the knowledge is not enough
Yeah.
to know
Well, I
all
can
the
assure
forces.
you that there's nothing you can do that's going to allow you to extract free energy out of a magnetic field.
I know that's low, but I just like to think.
Yeah. Well,
So,
I mean, you and many others are never going to stop trying.
yeah. So the question about magnetic shields.
Yeah.
Uh, my
Let me ask
understanding,
you
or
something. Here, hold. I need to know this because I get complaints, and I'm not sure with these hangouts. It seems audio levels are very sensitive. Like when I'm this far from the microphone speaking in this voice, is my voice coming through clear or is it distorted?
5x5.
Okay. How about if I get this close and I'm speaking to the microphone? Is this distorted or is this louder or what?
It's louder, like 6x5. So five is
But
5x5.
is it overloading or distorted?
No, it's not bad. I'm even using my earbuds,
Yeah.
but this is not.
How about if I get right here? Is this
No.
distorting now?
Yeah, it's so much.
Okay. All right. So if I'm here, this is fine.
Yeah, it's fine.
Okay. All right. Go ahead with your question or your statement.
Yeah, for the magnetic shield, my understanding, like if I have a magnet and it has the magnetic lines, or what do you call it, flux lines extending around it. So if we, of course, it extends to very far, but we will just focus on those lines that can affect something around it. You get what I mean?
Mm-hmm.
And so if I put some material that is called magnetic shield within this limit, it will condense the flux line within it. Is
Correct.
that correct?
Correct.
So in that sense, I can make the flux line of a bar magnet to be not extending as much from one side more than the other.
Yeah, basically true.
Well, so now I gotta share a video with you, and not the one that I shared now. Hold on a second.
I'll
It's
be right
called.
back. You
Oh,
get that set up. I'll be right back. I fill
I
my
don't have.
glass.
Yeah, I don't
I'm
have
getting
screen
dry
share.
in the throat.
Okay.
Okay. Now what?
Yeah, I'm just sending. I just sent it now. The second link.
I'm not seeing anything yet.
In the chat. I don't know how you get the chat on.
Oh, the chat. You're not
Yeah.
going to do a screen share, or what are
No,
you
I'm
doing?
on phone. I'm on phone. I cannot. I don't think I can screen share on my phone.
Let's see. Where's forgot where chat is on this stuff.
Like an envelope or a message icon.
Turn on captions, full screen. No, that's not it. These things change all the time. Chat. Okay, I've got chat now. All right.
Yeah, there's two links. The second one.
Okay, the second one. All right. Okay, Crow XE, RMM.
Yeah.
So what? You want me to watch this then?
Yes, it's just 1 minute only.
Yeah. Okay. Is there audio here or what?
No, no audio.
Okay. Well, first off,
Yeah.
going to, let's see here, at 15 seconds where you're showing, or 22, 23 seconds, you're showing your two poles. Well, when you put this magnetic material in there,
Yes.
the magnets now are going to be attracted to the magnetic shield.
Okay. So because there's attraction force, it reduces the repulsion force.
Well, yeah, they won't be repulsed by one another. The attractive force will swamp out the repulsive forces. I mean, the thing you have to remember in DC magnetic fields, non-changing, or what we call static magnetic fields, it's very hard that the shields work fundamentally different than they do for an electrostatic field. In an electrostatic field, you can totally shield out an electric field, like with a Faraday cage, because within a good conductor, an electric field cannot exist inside a good conductor. It has to be zero. So by enclosing a source of electric field by a good metallic conductor, you can render the field outside the Faraday cage or the conductor to be zero. Now, with a magnetic field, static magnetic field, that doesn't work because very low frequency magnetic fields and static magnetic fields can just about penetrate through anything. All you can do is what we call magnetic shield, is redirect the field lines. So if you have a very good ferromagnetic material like iron or cobalt, nickel, or something like that, you can redirect the field lines, but you don't eliminate the field line, because field lines can exist inside a ferromagnetic material, unlike electrostatic fields cannot exist inside a good metallic conductor, inside a good conductor.
They change to electricity or something like that, I think.
Say what?
They change into electricity.
No, not a static.
Okay.
No, not a static field. Time-changing magnetic field produces a electric field.
Oh, okay.
But
Yes.
a static field will not.
Yeah.
So what you do, so when you have like what we call mu metal, or very some material, a ferromagnetic material with a high relative permeability, what you do is the magnetic field lines concentrate inside that material, and you can change the distribution of the magnetic flux in the area about a magnet by inserting a magnetic shield, if you will, a material with high permeability.
Yes. So,
but a field can go through it. A field can go through it. The best you can do, the best high permeability materials might be on the order of relative permeabilities of 10,000. More typically, they're in the areas of 100. So even with the extreme high permeability materials, say where you have a relative permeability of 10,000, all you're doing is reducing the field outside that on the ratio of 10,000 to 1, but the field is still there. It's just reduced by that amount, basically, by the relative permeability. Is a good way to look at it, first off. I was going to talk about these things on Jose's show. I had a electromagnetic lecture all set up to go, and he decided he didn't want to do it. So I'll probably just make a video on it for people as a introduction to Maxwell's equations.
Well, such topic may not be welcomed on these channels because it's not really related to flat Earth. But you can make it related to flat Earth if you.
Well, there are some concepts. What I was going to talk about, how refraction works.
Oh, okay.
Why a molten magnetic core of the Earth, a magnetic field can exist in there. They bring up the Curie temperature, but they don't understand what the Curie temperature is. Things like that.
So anyway, for the video, did you see until the end?
Did I what?
Did you watch to the end of the video I sent you?
Yeah, I didn't quite get what you were doing here.
Well, I was shielding one side and not shielding the other. For the two
what is the red and the blue?
Poles.
So you have two concentric magnets, or you have a magnet that's Well, let's see if it's even possible. Let's see. Let me think about that. So, are you saying like these are two? This is a cylinder of material where the inside is one pole, the outside is the other pole.
Uh, uh, um, I won't say a cylinder, but
What is it? Well,
like a
this is a
torus.
cross section of what?
Yeah, cross section of a cylinder, but the thickness of the cylinder is small. Like
Okay.
the height from side view. This is from top view. If you look from side view, the height is small.
Um, just a minute. Let me think about this a second. So if this is a cylinder and this is a cross section of the cylinder, and you want the North Pole, say, to be on the inside, the South Pole to be on the outside, uh, you cannot do that in reality. That violates Maxwell's equations.
We cannot have magnets in that setting.
No,
Oh,
because there's a fundamental equation, one of the four Maxwell's equation, that tells you the divergence of the magnetic field, the B field, the electric magnetic flux density has to be zero. And picturing how the field lines have to be here, the divergence would not be zero. You can't, it's impossible to build this structure.
yeah. I think I'm just looking at a like when flat earthers look at Earth and they ignore the tilt and other things. Yeah, I'm just
Yeah,
looking
I
at
mean,
this.
what you're doing, this is the same problem I had like with Chris Monk building his flat earth model, or you using, they were talking about magnetic fields explaining everything. Well, the problem was is that he violated Maxwell's equations, and in building his model he didn't understand the nature of magnetic fields sufficiently, that he came up with a structure that could not be realized in the real world.
Yeah, I'm trying to imagining it. Yeah, but where is Chris Monk right now?
I have no idea.
Ah. I think when you talk about the model that he was trying to make, this reminds me of something that I saw on FE channel before it becomes FE. Uh, 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 Dr. Zach and Steve Torrance, they had this thing called the magnetic Earth, explaining how the stars and the sun
Right.
moves.
Yeah, whenever I've looked at these, at one aspect or another, there was a violation of the electromagnetic equations that you have, and the boundary conditions. You have to be able to satisfy Maxwell's equations and the boundary conditions that go with it in order to have a realizable field. Um, you know, you can come up with these configurations, but you might never be able to build them.
I think I could be very useful for you because I have the lack of knowledge of flat earthers, and I have the imagination, and I have the insistence. So when when you say Maxwell equations, what popped in my mind? Who's that Maxwell? I don't know him. Hence, I don't take any of his words.
Yeah.
So you should know who you're dealing with, and maybe you practice on me, so you can make sense of how do you
Well, I
think it.
don't know what to practice on until I hear a claim. See a diagram like this, and then once I start thinking about it, imagining how the flux lines have to be to that emanate from a structure like this, and I visualize what divergence and curl are, I can see right away that it's going to be a violation of Maxwell's equations.
Yeah, now when I imagine the flux line, I think there. Let's if we look at the bigger cylinder or the bigger rim, it goes from inside and scrolls and uh, outside and go into the red. I think it would go like for a cross section, it will be like a normal magnet bar. Is that correct? A cross section in this cylinder.
Which one? The smaller cylinder? What are you saying?
Either of them. If we cut one of them.
Well, you can't build that. You can't build a cylinder like that with the inner surface being a North Pole and the outer.
Oh my God! Oh, I didn't understand that.
Yeah, that can't be built.
So there's magnets that kind of look like this. Where is the South and North Pole for those magnets?
Well, they're not hollow inside, are they?
Yes, hollow. Like the ones on the speakers.
A speaker basically has the voice. You have basically a you have a gap. The North and the South poles come about. The flex lines are completed through the. I'm trying to figure out how to describe this. Is
I can look
what you have
images of ring magnets. Maybe may show that.
Well, here, let me do paint here a sec. Maybe I can build something real quick to show you what I'm talking about.
Okay.
Okay, I'll do a share here again.
All right.
You tell me when you've got it.
All right.
Got it now?
It's coming.
Okay.
Yeah.
All right. Let's see here. How would I do this? There's no freehand thing here.
You can do an ellipse. As if you're looking isometric. Okay, side view. That's better.
Whoops. Oh, come on. My mouse is jumping.
You can make a. Oh, okay.
Doing a cross section of a speaker magnet. The traditional voice coil speaker. I'm being kind of sloppy here, but
Yeah, I'm the same with these programs. So it's like a fork. That's a side view.
yeah. Okay, and the voice coil, of course, is here.
That's like the drum.
This is the winding. The windings, and then your speaker is attached. Your speaker cone is attached to this, and this moves in and out, going back and forth. This is a winding of wires. This is your magnetic field. Your magnetic field jumps the gap. The magnetic field basically goes like this. Let's see, follows around. This is a magnetic flux line. So you could say if it's going in this direction, um, then whoops. Oh, gosh. Come on.
Undo.
Yeah. Oh well, that's there for good. But this is your magnetic flux line. Magnetic flux lines emanate out of the South Pole, so this is the South Pole, and enter the North Pole. So we have, see right here. Oops. Oh. Come on. I guess I gotta type something. And my computer is. What is going on here? Huh. Weird. Come on. I think my system might be ready to start crashing. This is not good. Oh, shit.
Even with paint. Okay, it's back.
There. Okay. There's a North Pole. This would be the South Pole. And then another North Pole here. So your magnetic field lines are going in this direction. Yeah. And then you have, oops.
Similar one on the bottom.
Right.
Yeah.
Correct.
Yeah.
Oh. Well, anyway, you get the idea.
Yeah.
And then it jumps this way. So it jumps the gap. So this is everywhere along this edge is your South Pole. Everywhere along this edge is your North Pole. Mm-hmm. But here you have your magnetic field lines have to form closed loops. That's a requirement from Maxwell's equations. You cannot, magnetic fields always form closed loops. You can never have something like with an electrostatic charge where the magnetic field lines just start at some central point and go out indefinitely. They always have to form loops.
Well, if we get a magnet kind of flexible like the refrigerator, and one
like
side
what?
like
If we what?
Refrigerator.
Refrigerator?
Like, yeah.
What about
like the
it?
one, if you get a magnet that is flexible or a little bit flexible like that, and we have the North Pole at one side, the South Pole at the other side, and then we form a circle with this magnet. We can have this setting like
Let
a
me
show.
Let me think about that a second here. What's going to happen when you do that? Let's see here.
And you see those lines that I'm calling flux lines in this image. Those lines are
thinking about this a second.
Yeah, this is just a cross section of the flux line. So they are going from the red and coming up.
Oh, I understand that. I see what I just got to think about these flexible sheets of magnetic material.
Yeah.
Never really gave much thought to those as to how the field.
I know at the connection point there will be some issues. I know, but
I would have. I'll have to study that because I'm not sure. See, if we go back here now, let's say this is we're looking on edge to this flexible magnetic material that sticks to the refrigerator. All right.
Yeah.
So, um, the question is, um, what you're assuming is, whoops, what you're assuming is that the field is doing this sort of thing. Whoops. That the field is going across the thickness of the material.
Yeah, and going north and then it's spread
But
out.
the field might actually, now I have to think about this, might actually be, rather than going across the material, it's doing this sort of thing where, say, this is a North Pole. Oops. What the heck? Oh, there. What? Why is that changing? Let me think here. Let's try this again.
Paint is pain in the ass.
There it is. It could be more like this, where you have these sorts of things where the field lines are basically forming where this is also south on this side and north on this side. And basically what's happening is your field lines are going like this, south through the air, back to the material, then it completes the loop through the material and it's going this way, and then this one is going this way through the material, out through the air and back. So you really don't have north-south going across the material.
No, yeah, I think that wouldn't work. But if you look from the right side view of this sheet that you draw,
Yeah.
and you put, can you draw just a box as if you're looking side view?
Here, hang on. Oops. But what the heck? Why did that?
I think you painted something.
Yeah, it shouldn't be.
Just a
All
small
I was
box.
doing was cutting it out.
Oh, you're cropping, I think.
Yeah.
Oh,
No,
okay,
I cut
that's
it.
better.
Okay. I don't know why it came out black, but anyway. Let's move this up. Well, this is a side view.
Oh, okay, then look from the right side.
I'm not sure what you mean by the right side. See, what I'm showing you here is this. Here's the sheet, basically.
All right, do you see this that line on the right side?
Okay.
Look perpendicular to it, and so the north will be up, the south will be down, and then it will be like a fontaine going.
So if I'm looking on this edge, okay, here's the edge. I'm looking in this direction, going this way.
Yes, yes.
So I'm looking down the sheet, essentially.
Yeah, it will be a classical flux line going down and then curving to the left and right and going up and going in again.
Yeah. Well, let's just, rather than this be the thickness of the material, what I'm going to do is let's exaggerate the thickness of the material.
Yeah, that's good.
Okay. This is a cross section of the end.
Yeah.
Okay. And this is the thickness of the material here. Okay.
Yes.
So what I'm saying, what's probably going on here is the field lines are doing this.
Will be like two circles. Oh no, I don't get what.
This is what I'm saying is going on.
That's if north and south is are left and right.
So the field lines are going this way and this way. Let me draw arrows here, show you. So this field line is going that way. Whoops.
I was thinking the upper half of the section is north and the lower is south.
Yeah, I know, but I'm saying this is what I think is going on in reality.
Oh, okay, okay.
So the field lines are completing through the material like this. So this here, this end is your south pole. This end is your north pole. Whoops.
Yeah, I was assuming a 90
Yeah,
degree.
I know what you were assuming, and I don't think that's right. That's why it's in violation of Maxwell's equations. But this is an actuality what's really going on, and inside the material, the return lines are going like that on both.
And so if we squashed this cross section from left to right,
Mm-hmm.
at a certain point, these flux line will rotate 90 degrees.
Well, the thing you have to remember is that these flux lines, you know, whoops. Uh-oh, I didn't want that. Let's see. See, you have this sort of thing going on. You know, there's all kinds of these concentric ellipses here going on. And
Extending
eventually
outside.
what's going to happen is the field lines here are going to be doing this sort of thing, you know.
Yeah, yeah, you know.
What kind of shit diagram is this?
Oh, come on.
I've just come back and seen a lot of lines on a screen and George
You
playing
should be
about.
doing these things.
I don't. What is this? What are we looking at?
Magnet.
Oh, right, okay.
These are the reds are the field lines of the magnet. So this is what you're going to have, Khaled. And then, you know, you're going to have the same thing flipped down on this side. So this is how that magnet is going to actually look. Is
Okay.
the field
So-
lines don't go across the cross section in this direction, like, you know, I don't want that. They're not going to be doing, they're not going to be going through the cross section of the magnet like that. They will not be going in that like across the cross section. They'll be
All right.
going through the cross section.
All right. So if we found a way, we are looking into the length of this magnet, right? If we find a way to bend it to the right and complete a circle,
Mm-hmm.
that would be having the North Pole inside and the South Pole outside of the circle.
No. you're still, because the magnetic field lines have to form a loop, closed loops, you always have a north and south paired. The inside will not all be south or north. You'll always have little bits of south and north dipoles everywhere along here.
Oh.
What the one surface cannot be all south and one surface cannot be all north.
Yeah.
That would be in violation of Maxwell's equations and the boundary conditions.
Well, come on. Don't say Maxwell. I don't know Maxwell. Therefore, what you're saying is not true.
Okay. All right. Yeah, just like there's no Newton's laws don't exist.
All right, but I get your point.
See, and that's where the complication comes in. Is what you were trying to assume is that you could have one surface all being all south and the other being all north.
Yeah.
So when you wrap this thing around, say in a loop like this, the inside surface might be south or north and the outer surface the opposite polarity, but no, that's not how it's going to work.
Well, I told you that's why I left away magnets, because it's complicated, and I went to the things that I can hold with my hands: gravity, buoyancy, stuff like that.
Sure, gotcha.
Oh,
well, anyway, I think it's like 3 in the afternoon here, and I should go outside and get some work done. It's a beautiful day.
Yes. Okay. I enjoyed the time.
I
really.
hope that's helped you.
Yeah, it did.
But the thing is to remember that the magnetic material, like this flexible refrigerator magnet or whatever, all that serves to do is, you can think of it as being a shield too, is all it does is provide a low resistance path, or what we call low reluctance path, for the magnetic field lines. They're all going to go in one direction along the inside, not going across, but have to go along the axial length of the plane inside the material. They don't go across the material.
Yeah, and they so the poles
Like,
is
for
usually
example, yeah, go ahead.
Does the poles prefer to be along the length of a magnetic material?
Yeah. Well, there's infinite number of poles. There's just not one or
Yeah,
the other.
I get.
But yeah, like, for example, what this material is that, whoops, what the hell? What we're
because
looking
the north and
what
the
we're
south
looking
pole
at is
Yeah.
this, basically,
isometric. Yeah. Okay.
Holy shit, George! Your perspective. Oh no, you corrected it. That's a little bit all right. But yeah, it's still isometric. You could have put a little perspective in there, George, and a bit of vanishing consideration.
Why don't you go and kiss Jose's ass? He doesn't like me. Go rub your nose in his butt.
You know,
But
you know,
anyway.
George.
Yeah.
You know who should be doing this work for you? It's Dean.
Yeah.
Same
no.
as.
But
Yeah,
Dean doesn't like me, so he's not going to do anything for me. He's not going to do crap.
Dean, because Dean want to satisfy flat earthers and doing the flat earth model for them. He should satisfy me to make the free energy model that I'm trying to make.
Oh, you're not doing a free energy model.
I am been doing for 12 years. But I quit. I quit.
I was going to say, I didn't want to ask, have you been successful yet? Because I don't think you have you, in 12 years?
No, I debunked myself
basically, basically what I'm trying to tell you, Khaled, is this field could be oriented in any way. It could be at right angles where this return field is coming down this length. It could be going crossways. It could be going whatever. What the important thing is that inside the material, the field is all going in one direction after you've magnetized it. You don't have the field going across, the thickness. The field goes down parallel to the plane of the material is how the field is on the inside. It doesn't go across the plane of the material.
The way I make sense of it for myself is that the North Pole and the South Pole, they kind of hate each other, so they try to stay as far as possible from each other, and that defines the flux line direction.
Right. Yeah. Well, you could have the South Pole here, the North Pole here, the South Pole here, the North Pole there, South Pole here, North Pole here. It could be oriented in any manner on the sheet as long as the return field is inside the plane of the material, parallel to the plane.
Sorry, George, I've got a question. You probably explained this, and I've only just come back like in the last 20 seconds. But what dictates the field direction then in terms of the material? Is it the way
it has to satisfy Maxwell's equations and the boundary conditions?
But is it not how a material is ionized, as in how
magnetized? Yes. Yeah. Magnetization will determine the orientation of the field of where your net North Pole and the net South Pole is.
But I didn't get what you were saying. When it could be here, it could be here, it could be here. But how would we make it there? I don't.
Oh, you have to subject it to an external field. You would create an external field by an electromagnet or a set of permanent magnets.
Yeah.
Like, how we magnetize a nail. How do you magnetize a nail? You wrap a coil of wire around it and put a current through it. And it turns out that with a coil, if you say this is a coil of wire, you can imagine.
You still need a Mac. You still need a Mac.
Yeah. Well, I need a better draw program. That's what I really. But can you see my cursor okay?
Mm-hmm.
Imagine that you've wound wire around like this,
Yeah, and if I'm going clockwise, where the positive flow goes up to the top, is that where am I dictating the flow via the direction of the flow in that coil that I'm putting into it?
Yeah. Well, the thing is let's say.
Sorry, let's say like a dumbbell.
Yeah. What I'm trying to tell you is the direction of your magnetic field lines.
Mm-hmm.
When you have a current carrying wire.
Mm-hmm.
Let's say this is our current carrying wire, and our current. We talk about positive current flow in electrical engineering. So I've got positive current flow in that way, okay? Mm-hmm. Now, how you determine the magnetic field is what we call the right-hand rule. And the way that works is is if you take your right hand, you point the thumb in the direction of the positive current flow, then your fingers curl around the direction of the magnetic field. So in this case, that's how it would be. Is the current is going left to right, you point your thumb of the right hand left to right, then your fingers are curling around the wire. That's how your magnetic flux lines will be. Okay?
Mm-hmm.
So that's what I'm kind of showing there. This part is the front of the wire. This part is the back of the wire. Okay, I'll just kind of make it a little more realistic here.
And at the extents of those flux lines are the poles that will always be opposed.
Yeah. Well, by convention, we say a flux line, a magnetic flux line flows into the North Pole and out of the South Pole. That's what I'm showing here. Is this would be a magnetic, whoops. Is the arrows are showing the direction of the magnetic flux line here.
Mm-hmm.
So the flux line flows out of the South Pole. So that's why it's south on this end and north on this end. But it's all relative because there's no such thing as an absolute South Pole and an absolute North Pole.
Mm.
You don't have monopoles like you have positive and negative charge. Magnetic monopoles do not exist in nature.
Mm.
And we haven't even been able to produce them artificially either. So they don't exist in nature. So on something like this, where you have a current carrying wire, I could start here and say, this is the South Pole, because I could, or say the South Pole is right here. If I'm going to start on this, at this point, I'll call this, excuse me, I'm losing my voice again.
You're talking too much, George. That's what it is.
Yeah, I know. Without rumpusing.
Yeah, you've probably been rumpusing now for about 2 hours, haven't you?
Excuse me. And then, so this would be a North Pole. So if I just went on this portion of the magnetic flux line, we would call this point in space a South Pole, this point in space a North Pole, because the field line is coming out of south, going into north. But likewise, I could start and call this South Pole.
Yeah, I get it.
And over here,
Yeah, I get
North
it.
Pole.
Yeah,
Okay.
I get it. Yeah.
So it's all relative because there's no absolute north and no absolute south.
Cool, I get it.
And that's the difference between magnetics and electrostatics. Is with electrostatics you have two types of charges. In magnetics you don't. Magnetics, north and south poles always come as a pair in what we call a dipole. Wherever you have a north pole, you're going to have a south pole nearby. You can't separate them. And that's where a lot of people get buggered up and coming up with magnetic material configurations that can't be realized in the real world. Cannot be built. And that's what Callie was first proposing before you came here. Is what we were talking about, is this structure here that he had, that I was trying to tell him that you can't do that. You can't have on the inner surface of a cylinder. You can imagine this is a cross section of a cylinder. You can't have a North Pole all on the inner surface and a South Pole all on the outer surface, or vice versa. You just can't build that. Because that would require now, if you imagine this is the thickness of your cylinder, of your material, this requires the magnetic field lines to go across the cross section of the material. And what I'm showing you here, whoops, what I'm showing you here is that does not happen, because if you have a thin magnetic material like one of these flexible magnet refrigerator magnets that people put their business cards on or something like that, the field goes on the inside along, that's parallel to the surface of the material, rather than going across the cross section.
So in that diagram that's showing in my video, the North Pole will be, for example, toward us, and the South Pole the other side.
Whoops, what happened here? what I'm saying is, in actuality, what you've got going on here is a bunch of north and south poles. You'd have, say, a north pole here, a south pole here, north pole here, south pole here, and so on, or however you want to split it up. The field lines are going to be going this way, whereas what you're showing is the field lines going across. They can't go across. They've got to go through the. They've got to be parallel.
From our view into the screen.
For our view into the screen, the way your magnetic
Yeah.
field lines would be is circular on the
Yes,
inside
yes.
of the material rather than going across the material.
Hmm. But what if we stretch it? Forget about a cylinder. You have it like this stripe. We stretch it to make it straight. Something like the, what do you call it? The maglev or maglev. So we have the south pole up and the north pole down.
Oh, maglev track, you mean?
Yeah.
Yeah.
Yeah. Well, the thing is you have to imagine you got to figure out where the north and the south pole is. They always have to occur in pairs. So with the maglift rails, for example, let's say we have two rails. We're looking at a cross section. Whoops. Say we have our, and they're sitting on the ground. The ground is here. So we're looking at a cutaway cross section.
Yeah.
So with the maglev, what's going to happen is the field lines are going to have to be loops where, say, it's coming out here, looping out towards you, and then curving back and going back into the screen rather than going across or anything like that.
Oh, okay. Okay, I get it.
Yeah, like this isn't going to be north and this isn't going to be south, where you're going to have field lines going, between them in that manner. The field lines, rather than being in the plane of the page, is going to come out of the page, loop, and go back into the page down the length of the rail.
George, I'm going to put my CTO hat on now and say, all I'm hearing from you is excuses. Me and Khaled want to see results of a free energy machine. Now go.
No, there you go. Well, I'll tell you what. I've got a free energy concept.
Have you?
Yeah.
Oh my God!
I get a lot of.
Look who's talking.
I got. In fact, I've been making use of free energy for years.
Oh, okay. Solar panels.
I just go over at nighttime and siphon gasoline out of my neighbor's car. It's free energy.
Nice.
Yeah, that figures. Okay,
That's as close to free energy as you're going to get, Dean.
Yeah, I can imagine.
I'll try to make another design for this magnet thing, and maybe we discuss it later. And of course, I'll try to hold Dean as a hostage to draw it for me.
There you go. Yeah, well, Dean can draw pretty pictures. I'll give him that.
I can have trailing particles representing the flux lines as well if you want.
Yeah, that would be great.
Yeah.
Oh, what's this thing doing? Does this thing have like a voice translator or something?
I have no clue. I'm using phone.
Oh, what's going on here? In the bottom, are you seeing my screen?
Yeah, there's something is being written there. Oh,
yeah, I'm
it's
saying
like
there's a voice translator. It looks like
transcripting.
Yeah. This is for obviously deaf people.
Huh. Cool.
That's amazing.
That's pretty damn good.
And of course, if it has something like this, then it can translate.
Yeah, one of the interesting things is about 2 years ago, Google demonstrated both voice recognition but vocalization tech that they verbally asked to make an appointment. It then rung a barber's shop and had a conversation with the barber's shop to arrange an appointment, and the barber's shop's reception lady could not tell that she was talking to an artificial intelligence.
Geez, do you know, is there a way we can capture this Boy, this would sure save me a lot of writing. If I could just speak, translate what I want, and then go back and read the text and make whatever corrections I need rather than write everything. I like this.
Yeah, but George, a Mac does this. Get a Mac.
Oh, come
Yeah.
on, IBM can do it.
Oh,
There's speech.
until I get a Mac, is there some way I can utilize this? Do you
Yeah,
guys know?
Look in Chrome. What do you call it? These add-ons. There's something
Chrome
like
extensions, yeah, Google Voice,
extensions.
Chrome, yeah, something
Yeah,
like that. But
They
just
call
voice
it
to
Google
speech.
Voice.
no, it
Voice
isn't
to
called
speech,
Google
I
Voice
think.
actually. Wait a minute.
Speech to text or text to speech, something
Yeah,
like that.
Okay.
speech to
I like
text.
this. Damn, this would save me a tremendous amount of time.
Yeah, get a Mac.
Yeah. I
I
will.
hate
As
Mac.
soon as you're ready to buy, let me know.
They're not even. What? When's the fall? When's the fall? What the fuck is fall? Who's falling? Yeah, seriously. Whenever they are, they're launching around the fall. What the fuck is the fall?
Probably
Oh,
September, huh? End
so,
of September?
right, and I don't know. I don't have that over here.
Yeah.
So
Well,
end of
officially,
September.
fall begins September 20th.
Okay.
You know, that reminds me of something. For 15 years or 17 years of marriage, every year I forget the date of my wife's birthday, and I always shift it by day or 2 or 3 days plus minus, until I realized that she was born on the equinox, September equinox, and since then I don't forget.
Nice. Nice. Well,
And I told her, look, the flat earth is helpful because I didn't know these things before I joined the flat earth debate.
yeah, damn helpful that. Right. Anyway, guys, I'm going to get off now, and thanks for the teachings, George, and always a pleasure, Khaled. And I shall speak to you both later.
Thank you. Okay.
Bye bye.
Bye bye.